We are at the top of the hour. Great. Here we go. All right. Good to see you all again. Welcome to the second day of our IAB workshop on IP geolocation. I am Tommy Polly. I'm going to be chairing today's session. Thank you, Jason, for running our session yesterday, and John is going to be running the session tomorrow. A lot of these chair slides will be familiar to, but we'll talk about specifically what we're going to be going over today. Again, here's the note. Well, these are the policies under which we participate in IETF-related events, such as this one. Again, we are trying to have a very engaging discussion here. Yesterday, we had a lot of presentations. That was great. We have a number of presentations again today, but as we go through the agenda, we're going to be structuring things a little bit differently to have some longer discussion times. And as I mentioned yesterday, we want to end the session today with kind of creating a bigger list and collaborating on that. So I'm going to encourage everyone to think of the things they want to add to that list at the end. So yesterday we talked about a lot of the different, essentially like the status quo for, where are we at today? How do geofeeds work? How are people using things other than geofeeds to get geolocation? What are the different use cases? What's the ecosystem like? That will continue a bit today, but we're going to be trying to think about specifically what are some of the gaps and issues and explore some of the areas in which geolocation is being stretched and may not be applying as simply as it would. And we touched on a lot of these yesterday too, but we want to specifically focus on that today. And then going into tomorrow, will be more just like, big thinking, what are some of the other ways to approach some of the use cases and problems that may be different than traditional technologies. For the management, as yesterday we were using both hands and queue, I'm fine with either. I can monitor the hands or plus queue and create a list of people to comment. I'm going to jump ahead to what is our agenda today. So we have a first chunk here of talks that's going to be a little bit over an hour total, where we're going to have just different talks and different perspectives highlighting some challenges, anomalies, cases where things may break down. For all of these, we have a bit tighter time allocated to them, and I'm going to try to be relatively strict today on keeping to the time, mainly because we want to make sure we have ample time for discussion and kind of creating this broader list at the end. And the goal here really is for the comments and the questions to be clarifying on these, because what we're going to do is after this first wave of talks, we're going to have a 20-minute slot to just have broader discussion of reflecting as a group on all of these. So if you have things that are not just clarifying questions, please leave them to this time, and that way we'll have a good discussion where we can kind of synthesize topics and questions across all of the talks we just heard. We're going to have a break. Then we had several people who were very interested in talking about Starlink. So we're going to first start with Nathan's talk, going over the perspective from Starlink specifically, and then also have other kind of comments and perspective on that use case. Again, here, very minimal clarifying questions, and then have a discussion around that as a group. Then we're going to end with a separate talk on privacy impacts. And then we're going to have a larger chunk of time at the end to collate a list of kind of from yesterday and today, what are some of those gaps, issues. And here I think the idea would just be, let's get as long of a list from as many perspectives as possible. We can, at that point, I can like share it in the notes, and we can just essentially have the shared doc and just get everything. So as we're going through today, please be thinking about the things. Just take down your own notes of what are you seeing, what is it making you think of, and this is something that can help go into a report, and we can kind of understand. Here's the landscape. Here are the different things, and we want kind of all the different perspectives, both from we really need the IP geolocation, but here's a place where it breaks down. I'm sure there are also going to be perspectives here of IP geolocation is harmful for privacy and other things, and those are different, very different angles on problems, and we want to capture all of them in this exercise. Does that make sense? Any questions on the agenda or the flow here? Okay, sounds good. So with that, let's take advantage of time and we'll jump a little bit early into things. Oliver, do you want to start us off?
Sure. All right. Good. Can you all see my screen?
Yes, we can.
Awesome. Okay, cool. Right, then I'll get started. Yeah, my name is Oliver. I'm head of research at IP Info, which is an internet data company, but we do do a lot of IP geolocation, obviously, as one of our core business products. In this talk, I'm going to be talking a bit about geofeeds, and I was kind of, geofeeds have been mentioned yesterday a bunch already in talks and discussions. And I will be going into a couple of challenges that we at least had identified when working with geofeeds. So just to very, very quickly talk about what are geofeeds for people who are not very familiar with the technique. They're basically CSV files. You can see an example here on the right side, sorry, which specify a location or a prefix which is mapped to a location, right? And the location can have different granularity, country, region, and city. Postal code not really used anymore. It's kind of deprecated. Usually those geofeed files are referenced in the WHOIS database, or they can also be obtained using other means as well. And there are two main RFC, or the main RFC is RFC 8805, and then there is another RFC standardizing geofeeds. When we look back in time, we see that geofeeds are getting increasingly popular. So what we found that in September of this year, we had about more than 3,000 geofeeds that we downloaded and used as part of our geolocation pipeline. There were more than 7,000 WHOIS organizations using those geofeeds, and more than 450,000 IPv4 and 320,000 IPv6 prefixes being referenced in those geofeeds as well. And on the right side here, you can see kind of how this evolved over time, going back from December of last year all the way to September of this year. And what you can see already here, some interesting facts. I mean, of course, it's, as I already said, it's it's increasing overall, but we also see some kind of very weird artifacts, some of the jumps here, and which I will briefly also mention in the upcoming slides as well. So right, so now that we have geofeeds, all geolocation challenges are solved, right? Well, that would be nice, but there are a couple of issues and challenges that we identify, and over the next slides, I will go over those issues and also present possible solutions, which I would then be very happy if we can discuss about those more in today's workshop or also tomorrow. So one of the main issues that we see with geofeeds are ambiguous locations, typos, and mistakes. So, for example, here the full region name in this entry on the left side here is used instead of the ISO code, and there are also obviously encoding issues that you can see over here. Then a next example is the country and region fields which are swapped. So the country field should be AL should be here, and then AL-11 should be this field here. There are also cases where we have invalid ISO region codes here. So this should be GA-1 and not just 01. We also do see non-ISO country codes, for example, here Norway. which should just be NO, and also typo in prefix sizes, where for this IPv6 prefix, definitely wasn't meant to be like a /6 prefix, but instead a /64. So these kind of issues already highlight that there are issues which relate to the to geofeeds themselves, but maybe also with the location identifiers that are used in geofeeds. And one, so and especially this revolves around the city names that are ambiguous. And one of the possible solutions to go around this would be to add unambiguous location identifiers, or something like geonames or H3 indices to geofeeds as well. Another example that we've seen, and that probably some of you are also familiar with, are adversarial geolocation information in geofeeds. And some network operators, in fact, have an incentive to lie about their geolocation. So if you think about, let's say, VPN providers or so, they're always advertising X number of locations on their websites, and the bigger the number, I guess, the more impressed they think their customers or their potential customers are. And there are even guides on the internet, on the web, which tell you how to get an IP address geolocated in North Korea or Antarctica, where it's probably very unlikely that you're actually located there when using the internet. And all of these issues reduce trust in geofeeds. And what you can see here as maybe one interesting example on the right side is one of those jumps that you saw in the first graph was caused by an IPv6 network, which published a geofeed basically covering all 249 official country codes, and then basically not only that, but for each of the countries, they kind of list all possible, or a lot of cities, as you can see. So these are a total of 100,000 entries in that IPv6 prefix alone. And to kind of have or detect those adversarial locations, or kind of prove that those locations are in fact correct, one possible solutions that we could think about would be providing some form of looking glass service to facilitate the verification of these locations. Another issue that occur in geofeeds are false granularity claims. And region, and there are region and city fields in geofeeds, but those are optional, so they don't have to be mentioned there. And some IP addresses probably should not have a city level geolocation information at all. But some geofeed providers still publish city or region information for these cases, even if it maybe doesn't really make sense to do so. And one of the examples here, kind of this, maybe it's a bridge towards the next session. This is a large LEO network operator which publishes a geofeed where you can see, there's, for almost all cases, it's always the capital city in the geofeed, whereas very unlikely that all of their users are located in the capital city when they're using that service from that specific country. So I think one of the things that the community can do here is to increase the clarity in the standardization and operator communities that the region and city fields are in fact optional and must not be used just to have something in there, but must only be used if this level of geolocation makes sense for that specific prefix. Another issue that has already come up yesterday a bunch of times is user versus infrastructure location. And these iCloud private relay, satellite networks, VPNs, proxies, mobile roaming, all of these can cause issues where the user location is different from the infrastructure location. And this makes it challenging to also determine the veracity of the geofeed information, or also in general to have an understanding of what does this geolocation information in the geofeed refer to? Does it refer to the infrastructure IP address location, or does it refer to the user location? And there, I think this has already been brought up yesterday. It would be great if we have a possibility to signal the user versus infrastructure location in geofeed. So what does this geolocation actually refer to? Another issue that comes up is stale data in geofeeds. There is no real validity period that can be specified in geofeeds. and geofeed consumers do not know if the feed or entry are still valid or should be updated. The RFCs mention to use HTTP caching, but that's probably, I guess, very few consumers actually do make use of that, and it's out of band. It's not in the data, so it's difficult to kind of handle that. So specifying some kind of time to live or updated created times in geofeed metadata, I think, would be very useful for consumers of geofeed data. Another issue is the lack of feedback mechanism. So if there is an issue that is identified in geofeeds, there is no real straightforward way to contact geofeed publishers. The whois contact is not always the geofeed maintainer, and geofeed consumers need to rectify or simply ignore those issues by themselves. So if there, again, if we had some dedicated contact information in geofeeds themselves, I think that would make that a lot easier. And then finally, we also have geofeeds obtained outside of the whois. So these are either people who, for them, it's difficult, or the cost is too high to provide a geofeed and then put it in the whois. And these, what we find is that these are generally less likely to be RSC conformant. And I think here it would be great if there were some kind of a validation service or some service in general for geofeeds to lower the cost of deployment. Right, so I think that's pretty much all of the issues and possible solutions that I wanted to mention. So just to summarize, we at IAB Info, we think geofeeds are great. They're very useful to us. And but on the other hand, we also see several issues with them, which I've mentioned during this talk: ambiguous locations, typos, mistakes, adversarial locations, and so on. And I think it would be great if this community could make efforts to improve geofeeds going forward. Yes, that's all from my side. I'm happy to take any clarifying questions.
All right. Thank you for keeping to time. All right, clarifying questions. Let's just take 5 minutes or less for this. Matthew, go ahead.
Hi there. Yeah, this is just a quick one observation and maybe one idea. So the observation I would have is that some, you've mentioned the errors in the geolocation geofeeds files people publish. I've also seen some consumers of the files that actually treat optional fields as mandatory. So that's an implementation detail, but that's one problem as well. And then ideas, I think the RIR avenue might be one useful one to kind of solve some of the trust-related issues.
Yeah, I agree. I think that's, as you said, I think that would be a good way going forward. Yeah, I would agree with that.
All right, cool. Thank you, Joel, and then Jana. Again, clarifying here.
Yeah. So, I mean, we observe that city and sort of intermediate geographic distinction, which is mostly a political boundary, are optional, but there are plenty of prefixes for which country is completely inappropriate.
Yes, you mean like any cast prefixes or prefixes which are frequently changing?
Any prefix which appears in more than one country.
Yeah.
Like in it, like should not be anchored to a country level prefix, and like in many cases those appear in geofeeds today, either the ones that come from geo providers or from individual operators in ways that currently contain a false degree of specificity.
Yes. Yeah. And I think I guess also there I guess maybe the RFCs also can be improved in a way, right? Because if I remember correctly, the RFC says, okay, you can only have one entry per prefix, right? You cannot have multiple entries. So even if you know that you're peering in 3 different countries, that will result, I mean, for the geofeed file to be non-conformant.
I mean, you could make 3 claims or 5 or 100, but what does someone do with that?
Yeah.
Like,
All right.
Right,
We're
and
gonna
yeah.
go through the, if we can, just let's keep going through the list of folks. Again, please, for this section, clarifying questions about the talks. If you have other comments to make or other things to add, we're going to take those later. So if you don't have a clarifying question, please get out of the queue. Jana?
I think this is a clarifying question. I'll try. Thank you, Oliver. Very quickly, you mentioned using perhaps TTL as a way of indicating the life of these feeds. What does one do if the TTL expires? What does a consumer do in your mind?
I mean, just from our perspective, it would be good to know how long we can rely on this geofeed information that is mentioned, on the location information that's mentioned in geofeed, right? And then when the TTL expires, you would refetch the geofeed, which, yeah, I think that would be the straightforward use case for that.
Got it. So refetching. Okay, thank you.
Yeah, sure.
Robert?
I hope this is clarifying too. There might be no answer in this moment. Like, what happens if the TTL is of some very small value? Because I imagine having it very high might constrain the operator and how they would use their
Yeah.
address space. So anyway, might be no answer in this moment, but
Yeah, I guess, I mean, similar case as in DNS probably, right? So maybe we need some kind of a lower bound and upper bound values to be specified in an RFC or so that says, okay, it must be at least, I don't know, a couple of hours or so. Otherwise, it really doesn't make sense to refetch every 60 seconds or so.
All right. Robert, then Jeff, then Jeff.
I wonder how much of this is solvable by, I don't know if it's updating or a new protocol, but basically, if only this field and that field and that field and that field existed, this could work, right? So, original source URL, TTL or expiration, in the fields that you mentioned, in theory, they are possible to add, but would that actually help? Would that solve the issues that you think you observe with this format?
I think
Is it
some of them,
salvageable, so to say?
right. I guess the question is always like, what's the alternative, right? I think just as a, from IP Info's perspective, I think geofeeds are great, right? Because it makes a way with everybody using a custom format, and then you have to adapt to publisher X using this format, publisher Y using a different format, and you have to write all custom parsers to facilitate or to take care of that. So in that way, geofeeds are great. I think there are a couple of shortcomings in there which could be solved, maybe using the proposals that I made, but maybe something else or some variations of them. And I think that's maybe then what this workshop is all about, to figuring out, okay, are these good proposals? Should we change them? Should we change geofeeds? Should we get rid of geofeeds? Yeah,
I agree, and not even trying to preempt that conclusion. It sounds like a lot of the problems could be addressed already by standardizing the comment format and then basically making it an extensible protocol.
Yeah. Yes, I agree.
All right. Jeff Houston.
What we find is that the various bodies that publish national data, UN, ITUT, World Bank, CIA, World Factbook, all have very subtle differences in what they name a country outside the two-letter codes, the actual English text, and also, in fact, what is a country, because ISO 3166 can be misleading with things like overseas territories of France. All hope is lost when you drop into the name of a region, or God forbid, what is a city? There are no standards. How do you create canonicalizing geofeeds to actually allow you to mesh across multiple feeds with multiple different nomenclatures?
Yes, and I think this is a problem that we run into frequently. Right, the French overseas territory is a very good example of that. I think one of the things that would be useful for us is to have identifiers such as geonames where it's clear what that specific identifier is referring to, or maybe H3 indices at various granularities, right? You can say, okay, it covers this area, it covers another area. I mean, that's all very technical, and then I guess the hurdle increases to maintain or to simply write those geofeeds if that's how people do it. But that would be one possible avenue.
So you're assuming that there is such a canonical form, and let me ask right at the outset, is that political or geographic?
I mean, so
this may not be an answerable question.
Exactly.
The H3 indices are just it's just a polygon in a way, or you know, so it's I guess non-political in a way, right? The geonames might be political because depending on in which country you are, naming changes and you know, perceptions of countries or economies, as AP Nick calls it, changes, right? So that's then the territory that we go into. But technically speaking, I think there are ways of trying to avoiding those issues.
Thank you. We are at time here, so we're going to ask everyone else who has their hands up, please put your hands down and drop any questions into the chat. We can continue them there. Next up, Algapan.
Yeah. Let me just
and share. Thanks, Oliver.
are you folks able to see my screen?
We are.
Right. Yeah. Hi everyone. I'm Alagapan from University of California, Irvine. So in this talk, I will introduce a GeoTrace, a lightweight method that we have designed that uses existing traceroute data to detect and correct errors in IP geolocation. So we actually came to this because my work kind of heavily relies on traceroute and infrastructure geolocation, and we kept kind of seeing limitations that interacted in surprising ways and distorted our results, which is kind of what motivated us to do this project. So many of you know that IP geolocation can be quite inaccurate and inconsistent, especially when it comes to the city level, and different databases often disagree even at the country level. And when we come to trace routes, it has its own set of problems like MPLS tunnels that hide parts of the path and interface address variability that can make hops appear in different wrong locations. And when you combine these two imperfect tools together, the errors just compound and you can very easily draw wrong conclusions when you do studies based on them. Now, to understand how widespread these issues are, we analyzed about 7 million trace routes collected from Ripetless over a single day, which covered about 230,000 unique IP addresses. Using GeoTrace on this dataset, we found about 5% of the IPs which got tagged by our tool as having anomalous geolocations. But surprisingly, these IPs touched about 20% of the links and more than half of the trace routes. So even a small fraction of the bad IPs can contaminate a very large share of measurements. So there are several root causes on why this could happen. One of the root cause is like the fundamental inconsistency across databases. Different providers use different data sources and heuristics, like it was presented yesterday by a lot of folks. And when we aggregate them, we often see even conflicting city and even country assignments for the same IP address. After a simple speed of light style validation, only about 30% of the IPs end up being mapped to a single city, which suggests some deeper methodological issues for infrastructure geolocation that we need to be aware of. On top of this, the traceroute itself introduces artifacts through MPLS tunnels. So within an MPLS tunnel, all visible hops often share the same round trip time as the tunnel exit. And opaque when we come to opaque or invisible tunnels, they hide intermediate hops entirely, which makes it hard to reason about the two geographic path, especially over long distances. Now, interface address variability is another issue for trace routes, especially when it comes with geolocation. Routers often respond with off-path interfaces, so the trace route can show this off-path interfaces, which we have found that is especially problematic near AS and country boundaries. where the precise location actually matters. Now, although there are some ICMP extensions that could help there, our deployment so far appears very limited. Now, given all these challenges, what we saw, what our key insight was that we have a lot of existing traceroute data that already contain a lot of information to spot many of these problems if we can analyze them in aggregate. And we plan to do this with GeoTrace that kind of follows 4 stages. So first, it aggregates geolocation from multiple providers like MaxMind, IP-Info, to name a few, and then we group them by the city. Next, we evaluate how well the neighbors' RTD differences align with the geographic distance for each geolocation candidate. We prune away poorly performing candidates at each round, and then we iterate this neighbor-based consistency check until all the candidates stabilize. Now, here's a simple example of what happens along a single trace route in one iteration. So suppose we have hops AB, IP A, B, and C over here, and GeoTrace assumes that it has reasonable locations for A and C along with the RTTs. But we have multiple candidates for the cities, candidate cities for B over here, like Munich, London, or Paris. So if none of the candidates' IP's location can successfully match the observed RTTs to both A and C, we kind of tag them as anomalous if this phenomenon is observed across a lot of trace routes. And to eventually identify and potentially identify and correct some of such IPs, we use some of the neighboring hops from which we believe that we have trusted geolocations as kind of anchors, treating them like virtual vantage points where we have some location RTTs, which gives us constraints to identify where this anomalous IP could actually be. Now, with this iterative mechanism, GeoTrace actually does 2 things at once. First, it improves the database inconsistency, kind of consistency issues for non-anomalous IPs and identifies what could be the anomalous ones. And for the anomalies, we first distinguish them into MPLS affected IPs, where the pattern of anchor IP suggests tunnel effects that we currently flag. We don't correct it yet. We are planning to do that later. And for the interface affected ones, we applied some constraint-based methods using these anchor IPs, which I mentioned earlier, to resolve more accurate locations. Now, this slide briefly details the stats breakdown at varied glandularities for the various issues which I mentioned. So what we are able to do is, like I mentioned, we identify 5% of the IPs to have problematic or anomalous geolocations, of which we are able to correct about 2.6% of the IPs, which are the interface affected ones. Now earlier, like I mentioned, if we clustered the databases locations after basic speed of light validation, what we saw is only 30% of the IPs end up with a single consistent geolocation cluster. Now with just employing GeoTrace without using any active measurements, we see that it jumps up to nearly 60% of the IPs converging to a single Slatey cluster. And for the IPs where for the IPs where that GeoTrace actually corrects, we also looked at how far the resolved locations are from what the databases agreed on, and we see that only about 5% of the corrected IPs have a distance less than 20 kilometers from the database location, with the average distance being about 1500 kilometers, with the maximum being a surprising 17,000 kilometers. So this shows that there are actually many instances where even consensus across the databases can actually still be very wrong. And next, we also then wanted to ask if these errors show any geographic patterns, and in fact, they seem to show some specific patterns. So what we have seen is geolocation databases tend to overassign anomalous IPs to certain Western European countries like UK, France, and Germany, while underrepresenting regions like China. And we see that for the 30% of the corrected IPs, they have a country level disagreement between GeoTrace and the database consensus. Now, these anomalies have very real consequences for how we use the traceroute and geolocation today. We believe domains like topology mapping, which is what we do, and infrastructure analysis may be flawed if we don't utilize the geolocation carefully. Further, areas like censorship and regulatory compliance could also be impacted by these anomalies. Now, to kind of wrap things up, geolocation anomalies in traceroute data are common enough to matter, affecting via more than half of the traceroute which we studied. Database consensus is actually very limited for infrastructure IPs. And there are also network features like MPLS and interface variability that compound these database errors. Now with GeoTrace, we show that there is a lightweight neighbor-based approach using only existing measurements, where we can systematically detect many of these anomalies and even correct a large fraction of them using only the existing data. That's all I had today. Thank you for listening, and I'm happy to take any questions now.
Fantastic job staying on time. Thank you. Clarifying questions. Again, please, clarifying specifically. We'll have more discussion time later. Drew first, please go ahead.
Yeah, hi. Thanks for an awesome presentation. One quick question, especially comparing with the previous talk where we had all these ideas of how to fix things. Imagine those are in place. Would the solution that you are, the issues that you are highlighting, those will still remain in place, right? Like those will
Yes.
not be able to solve. So that's the
So
conclusion
it
you're
could
making.
potentially solve some of these. Like I think earlier in the talk, there was this discussion about like some of the prefixes being at the country level, they just assign prefixes and maybe the geolocation database they're picking up that. So in this, what it does is it just it does consistently checks with RTTs. So if the RTT is saying that it's not going to be in this country definitively, so then this one can actually identify and correct that, okay, this is going to be in a different country based on the RTT profiles which you're saying. So some of those issues which I mentioned earlier could be fixed by this approach.
Got it. Thanks.
Thank you. Caitlin.
Yeah, I had a question. It looked like on one slide you were talking about both errors in the geofeeds and then lack of coverage. I was just curious if you could speak more to that.
Yeah, so with coverage, I think different databases have, so this one's not specifically related to geofeeds. I think we are more looking at using, this study is mostly done with different commercial databases like MaxMind, IPinfo, and a few others. Obviously, geofeed could also be used. We can basically integrate what this tool basically needs is, it just needs like an IP address and the location and latitude, longitude. That's all this tool needs. So it can be geofeeds data, or it could be RDNS based location hints. Any of those could still work with this. With coverage, different databases have different coverage. I'm not sure if I can comment how much coverage each would be, but we did see that for the commercial databases which we looked at, the coverage varied from 60% to 90-95% across the IPs which we did in the star study. And for inaccuracies, I would say because we don't know what, when we compared it, so obviously for 90-95% of the IPs, we were able to find at least one geolocation database which we believe that has given a correct location. For the 5% of the IPs which we feel that none of the databases gave a correct location, so that's where we go ahead and try to do these corrections.
Thank you.
Lee.
Hi, I think you may have partly just answered this question. When you say 30% consensus among databases, you're talking about 8 databases. Does consensus mean all of them agreed, or a majority of them agreed? Is there a rough consensus, or what's the percent?
Yeah, so I think after doing speed of light validation, we wanted at least all of them to agree, or at least a majority fraction of them, like a greater fraction of them to agree. Like if we say that, okay, we poll 8 and the majority says that it's this specific location, then yeah, we consider it's consensus. If there is a consensus.
Okay, I think.
All right, Jeff.
Very quickly, trace routes, of course, often use asymmetric routing, where the
Yes.
return path has very little to do with the forward path. How do you accommodate that in your analysis of various trace routes? Because what you get back
Yeah, so
as an
for that,
RTT is a round trip time, not a one-way delay.
yes. So we do try to accommodate that by relying on Paris trace routes, which try to alleviate some of these specific issues. Obviously, there are like other specific patterns which also does occur where, like you mentioned, there could be still, even after using as Paris trace routes, there could be this asymmetric RTTs. So what we try to do is the idea over here is, rather than just relying on one signal, let's try to look at across all multiple paths. It's not like you're relying only on a single trace route or single path. Like let's say a specific IP might be present in maybe thousands or tens of thousands of trace routes. Maybe some of them will have issues, some of them won't have that asymmetric path issues. So the idea is, when we look at a lot of these data put together, so they might average out these issues, is what our assumption is. This builds on the top of that assumption.
All right. Thank you. I think that is our cue. Yeah. All right. Thank you so much for that talk. Very interesting data.
I see hands up from Caitlin and Lee. Did they get covered, or those still?
They already. Or I assume those are left over from their previous comments. Yeah. Thanks, Richard. All right. So next up we're going to have a talk from Om Prakash Sharma. I'm not seeing them on the list of participants here. Cindy, did you see if they were on the call?
I'm not currently seeing them. I did see them yesterday.
Okay. We will then rearrange or skip over that for now. If they join later, then we can get to that. All right, Nalini, would you be fine with going now? Sorry to put you on the spot. There we go.
Nali, you're on mute.
Yeah, we can't hear you if you're talking.
Okay, can you guys see my screen?
Yes, we
No.
can. Yes.
Oh, you can?
And we can
But
hear
you
you
see
now.
the.
So we see your web. Yeah, they hear your slides. Go for it.
All right, so now you see my slides? Or no?
Yes, we do.
We're good.
We
We're
see
good.
your slides. We're good to go.
Okay, thanks. All right, so okay, I'll do this fast. So first, just I have a different perspective from some of the people that are talking here. So we, my company is an independent software vendor, and we create products that are used by large enterprises, you know, the Morgan Stanleys and Blue Crosses of the world. And so we take in the geo feeds that a number of these folks were talking about and use them for various purposes that these people need, and there's different needs, and so and a good deal of it where it doesn't work is for things like fraud and you know, vulnerabilities, people trying to hack in and so forth. Where it does work is when it's our own infrastructure. So like a branch office is using a poor version of TLS, or a bad cipher suite, or a business partner is not doing something accurately. It works. That's you can rely on that IP address. But of course, the problem is when you have an attacker, and so as we've talked about before, is that you know, adversaries routinely evade these things, and so I'll get stuff like this IP address is coming from Microsoft Azure, and so Microsoft Azure is the adversary. I mean, and we take in a ton of different feeds, and try and cross-check, as the gentleman before was talking about. And again, as I say, as has been brought up before, so I'll skip past it, is that people, it's outdated, and you know, the addresses can't be relied on. IPv6, some folks have very limited IPv6 coverage. And again, as we've talked about before, proxy networks, mobile IPs, and so forth, what we really need is the origin of the VPN or proxy. Yeah, and I'll show you, you know, in a minute why. Because these guys switch IPs very frequently they'll split it, spin up a new cloud resource in minutes or seconds, and you'll see what some of the threat examples are. I'm sure you've heard about a lot of these things. Is in North Korea, they had quite a few remote developers, and they were saying that they were from the U.S., and this has been in the news lately quite a bit. Stuff coming from Iran, Russia, China, so forth, and a good deal of this ends up in becoming ransomware attacks, and this is it's a huge problem. One of the folks that I work with, as we were just talking, I said, how many did you have? How many IPs did you block in this past hour? And he went and looked, and his organization, which is not even one of the biggest I deal with, and in the past hour, they blocked 39 million attempts. And I've seen stuff at the IETF in various things about, don't do IP blocking, but then, well, you tell me what to do, and you tell me how I'm going to get a firewall to work. And so the folks that I'm talking about, this is your bank, this is your healthcare system, it's your government, and so we'd like to find something that works. So, yep, there we are.
Thank you for that other perspective. All right. Clarifying questions. Marwan, go ahead.
Hi, Narini, thank you. I think it's interesting and I can imagine provocative. The question I have is, how does knowing the location actually improve any of this? Like, I know people want, right? But like, let's say we somehow manage to find an accurate location. Okay, if you're North Korea or you're Iran and there's export rules and so on, I get it. But I don't understand how knowing the location of an IP address, if there was a way to do it, actually helps this cause.
No, I totally hear what you're saying. It's more likely. It's an odds game. It's more likely that this person should not be accessing my system. Let's say, for example, if I'm Blue Cross of Alabama, my coverage area is the state of Alabama. It's of course possible that one of my customers is currently in North Korea. But then what it leads to, this is only, I mean, this is why I have a business, is because once I see that, then I'm like, okie dokie, let me see what said person is now doing. Then let's see, now we can do some more intensive investigation. It would be an opportunity for me to start doing packet traces, and in particular packet traces where I know you guys didn't hear this word, where I could see what the person was really doing. And we own the server. We own the server, so we can decrypt the data and see, is this guy, what's he doing? Is he trying to do brute force attempts to get into RDP? And what's he trying to do? Is he trying to do a port scan? Am I making sense as to what I'm saying?
I think so. I still don't understand how IP, like for geofencing services and stuff, I get people have a need and hopefully there's better alternatives. I think I'm still like, as a signal to do something else, I'm less convinced, but I appreciate the clarification.
Yes. It's a probability. It's a probability. Because a lot of this stuff is probabilities. You don't know. And so now it's a probability to start doing more active investigation onto that. Does anybody else kind of understand what I mean? Maybe I'm not explaining correctly.
Yeah.
Help me.
We do have other. Do you want to just get in queue? Is that okay, Rob?
Yeah, I was responding just to that. Let me raise my hand here. I'll get in queue.
Okay, great. We can end up taking things out of it. Drew, do you want to just go ahead and then we'll kind of filter things through?
Thanks, Nalini. Nalini, one thing which I just want to add to what Marwan was saying, I think one clarity we would need from you is from an enterprise point of view, as an output of this workshop, would you want the IP geo feeds to improve, or would the output should be that, oh, we need a new solution because of the various issues that you are also highlighting? So from your presentation, it's unclear where are you landing on this debate. Are you more leaning towards we need to fix or we need to redesign things?
No, okay, yeah. So I mean, what I wanted to do is I wanted to present the actual use cases, where actual people are using this stuff for actual problems that happen every day. And there's both, because I think one, yes, what you have, if you can improve, great. We take that. But one thing, like I said, is what we really need, I would say, is endpoint, the ingress point of a VPN, something like that. Where are you coming in from? But the other thing too is like IP churn. That can be, people can say this thing address, because we do that with like web addresses. If you have a web address, it's like XYZ and 123 dash. And and he got it 10 seconds ago. Okay, probably, okay, wait a minute, what this is. And same with like IP is like, he got this address. One, he got it from Azure. And he, and you see what I mean? The churn. So the answer is yes, we need probably both, because I think the Wi-Fi business that the gentleman from GeoComply was talking about is nice, but is not enough. And so, and don't get me wrong, I'm not saying I have any answers. I just saying this is the problem from my point of view.
All right, thank you. Joe, then Rob.
So I think what I heard you say is that you have a bunch of requirements for being able to build heuristics around a particular kind of traffic so that you can make decisions about that traffic. And today, a key heuristic, perhaps because there's nothing else, is the geolocation of the IP address and perhaps the rate at which the IP address changes, things to do with IP addresses. Is that right? I mean, I think what I've heard is this is kind of the best thing
that's one thing. Yeah.
If they
and
had
we can
something
do
better,
other things.
you might use something
Yes,
better. I think the real value,
Yes.
I've just finished my thought. I think the real value that for me would be to understand the actual requirement that you have, not the way that you're using geolocation right now, but to understand what you're actually trying to achieve with this, to see whether or not there are other ways to contribute to it, and understand how much that should frame any solution to what we do with GeoIP.
Yeah. No, totally. So what I can definitely, yes, I totally hear what you're saying. What I can do, if you guys are interested, is like kind of write up something and send it to the email list by tomorrow morning about like exactly how I would figure out, like if some guy, some person, male or female, is trying to attack, is a good candidate for me that is trying to attack me. Yeah. And then what I would do once I see somebody, once I think somebody is attacking me, what I then do. And I think maybe if I write it up, that might be more useful. And hey, you know what? If there's other ways to do this, I am all ears. We just use geofeed. We just use geolocation as one input. And of course, like somebody said, rate of traffic. And then of course, some things very suspicious. If somebody coming into RDP a bunch of times, well, that already suspicious,
All right, thank you. And yes, in general, people, please feel free to use the list and we can send other more detailed thoughts and write-ups to there. Rob, I'll have you go, and then we'll transition into a bit of a broader discussion. some thoughts. And yeah, that's good stuff. Thank you for this.
Yeah, sure. So back to the geofencing question, the and then what question. IP addresses that show up in the ecosystem of a transaction are part of a much wider sort of anti-fraud thing. And the better the value, it's not just, oh, you can't log into your account when you're traveling overseas. The folks I have banking relationships with have somehow managed to figure out that buying radio or electronics equivalent or equipment stuff from shady locations in Ukraine or Belarus, that's 100% me. That's okay. And other stuff they flag appropriately. So the veracity of this information is really key to having an ingredient in this complex recipe that hasn't turned sour.
No, absolutely. No, I couldn't agree with you more. It's for a number of different things. I mean, there's fraud, but also, like I said, is the prelude to a ransomware attack and so forth.
Yeah. Yeah, I'm looking at this through the lens of just having spent 5.5 years at a big bank. So that's my that's my 2 cents worth. Thank you.
Yeah, thank you.
All right. Thank you all. Thank you, Nalini. Okay, so now we're going to go into some just broader discussion around kind of all of these talks, kind of the things that were coming up for you. I'm going to selfishly jump in queue as an individual here, but please, everyone else queue up. Just based on some of the things that this last talk was bringing up, and I also kind of have some questions from the group based on that. It felt like one of the things that, Nalini, you were touching on is something that, at least I don't think is, written down, standardized in any of the geofeeds, but is often something that's related to the geofeed products we see. And I know we have some geofeed vendors here, of the IP reputation and categorization of IPs. And I feel like there is some intersection here when we're talking about some of the discrepancies and issues, and the fact that certain IP prefixes fundamentally are behaving differently, and like they're not just a residential, this is someone in this town. So the fact that there are in these broader feeds categorizations to say this is a proxy, this is a VPN, this is something more like a CDN address versus something that is a residential one. And so I'd love to hear comments from people who are working on those of how they see that interacting with the IP geo feeds and other categorizations. Sometimes that could potentially, besides being a solution for helping the security aspects, also help understand when you are seeing this discrepancy of, oh, it looks like the hardware that this is coming from is in one place but is representing a user in another place. That is a proxy functionality, and being able to categorize that may be able to help. Just as an anecdote, because when we did iCloud Private Relay, we're intentionally doing a lot of this. There are some really funny things that came up that I think were intentionally, like, we're trying to be around the security blocking. Nalini, you're mentioning being in Alabama. Like, there was a case where a bicycle repair shop was blocking all traffic from like seeing your what hours the bike repair is available if you were not in the California Bay Area. And because it kind of miscategorized the IP we were coming in from, I could not look at the bicycle repair shop, which was kind of like a silly breakdown here. And like, I'm not sure that was really achieving the security that they were going for. And, I think there are cases, of course, where you have adversarial people who are trying to hide their location. But in cases like what we're trying to do with the proxies for iCloud Private Relay, or I think other privacy or security focused things that may be changing your IP, there would be a desire to present the correct location of the user. We have the feeds that are not the location of the actual proxies you're coming out of, but are representing where the user is coming from. that's not a standard thing. And I think one thing, Nalini, to what you're saying is like if you could have, some, maybe it's not just based on the IP you see the traffic coming from, but from some other attestation of the original user's geolocation, based on what their original IP was, and that could be transitively sent. That's the type of thing that would allow you to trust traffic from a proxy versus to not trust it. That's all my sense there. I think Nalini and then Marwan had their hands up. And people just feel free to get in queue. We're going to keep going for the next 20 minutes or so.
Yeah, Marlon, why don't you go ahead? I've talked a bunch. I'll go after you. Mhm.
Go for it,
It's
Marwan.
not like I've said little, Nalini. Look, I will point out, we wrote something a couple of weeks ago, and currently thinking about the peer review game again around carrier grade nets, right? Like, so there's a version of this which says, it's not just about where a thing is, because like, I think the risk is, look, IP info and MaxMine and all of these, like every one of us tries to characterize the use of these things. There is a danger, I think, in actually taking action. So 2 use cases are carrier grade nets. I think that's obvious. Any user of a carrier grade net has no idea they're behind a carrier grade net. IPv4 addresses are not distributed evenly across the world. And actions that are taken as a result of anything that's, rate limited and so on is going to disproportionately affect people along socioeconomic lines. That's, one thing that we need to think about if we're going to, as part of any standard, say the use of the IP address is X. There's a different version of this, and I'll tell you because we had an internal incident about it, which is simple tricks to identify VPN IPs. It's not hard. We all know how to do it. And so internally, there was a service that ran for a very short amount of time that customers enabled to block traffic coming from VPNs for very valid reasons. And then there was an incident because suddenly the machines at the data center couldn't get security updates because, a computer does lots of things, not just one. So I think these are the sorts of things we need to think in mind. But I'm a big fan of, yes, I'm a citizen of a country outside the country. I would like to access the government websites, and we can think of anonymous credentials and HTTP whatevers. I think to propel that game forward, that's entirely reasonable. And hopefully we can shift at least part of this conversation in that direction.
Thank you. All right. Nalini, do you want to go and then so I can keep the order sane?
Sure. So yes, I think some kind of attestation or credential or something I think is great. I see the WebBot auth. I mean, the WebBot, that is a very interesting, because that's another whole category of stuff which is all coming out now, is all the bots. And then how come you coming over to my site, and how come you scraping my stuff? What the heck are you doing? And also too, it's like, for people, I mean, this is going to create a morass, but it's like if I have a bunch of AI agents put in, where are they going out to? That also is an interesting thing. Why he have a need to go out to North Korea, and so it's one factor. And you get into the thing is like, if somebody is a good player and they authenticate, then of course the bad players won't, or they'll. I mean, it's tricky, but I think that if you have a system where at least good people will play by the rules, that's at least one set of information. And if some bot or somebody says I'm not, then I can also start looking more at their behavior and say, well, you sure look like a bot to me. And so, I don't know if I'm making sense, but there's this categorization is very important. And if we can somehow at least trust some, I mean, it's a great start. This is going to be an incremental approach. This is a big problem.
Thank you. Jeff Houston.
Yeah, hi. Look, it's interesting, Tommy, that you bring up issues around trust and authenticity in this area. So let's actually focus in on Apple's private relay. Who am I trusting? Oddly enough, I'm trusting Apple because no one else knows or can know. Now, I'm an Australian. I have a government. I have almost a regulated form of trust. And I know that the bodies that operate under Australian law have accountability. I cannot claim the same for Apple. So when a local ISP claims that they are deploying some attribute of the internet in location Y, and I'm going to sort of generalize it up from IP addresses, there is a certain amount of stick and carrot around that. You know, if they're dishonest, someone smacks them around the head at some point, in theory, because they have the authority of the state. Apple can lie their head off. And in fact, you know, there are anomalies inside this private data which are unaccountable, unverifiable, and ultimately untrustable by the very nature of the fact of the privatization. On a more general thing, and let's just shelve this in for tomorrow and just point out that in using IP addresses and stacking them full of attributes, including location, we really are the curators of the horse and carriage. The rest of the internet has moved into the namespace, and IP addresses are now a dim artifact of something that's decades old. And trying to stuff more trust and more attributes into addresses is really misguided. But you know, we can have that debate tomorrow. Thanks.
Christopher.
So one of the things that, I mean, what I'm hearing from the most recent presentation is that a lot of times people are deploying sort of aggressive geo-blocking or security kinds of applications using, and even the bike shop is like almost a silly example, right? Like they are utilizing geolocation, IP geolocation for a purpose that it is essentially like not that great for. Like MaxMind's been around for a long time, and I think some of this is just like a legacy of how much things have changed over time, right? A lot of these applications are built and haven't changed that much in many years, but like in terms of getting towards more sophisticated applications, I do think that there's like a role for potentially like standards and like modifications to the geofeed format to play in terms of some of the metadata we were talking about, because a lot of the context that we're discussing as being like important to understanding location and how that matters is actually stuff that I think data brokers are already thinking about when we make location choices. So for example, when we know that something is an iCloud private relay address, we think about location differently and we sort of prioritize our signals differently. One of the things that we found a lot of like headway with is that network operators are willing to disclose more about how networks are being used when they understand that this has implications for IP reputation, like data that's being sold, when they understand that there are other ways that people are using this in more sophisticated, I guess, applications. So there's definitely like the road to figuring out how to guide people to use the data better for these kinds of applications. But then on the other side, we need to get better data about like the context of these networks to make those applications work. That's just a thought. You're saying willing or feel there is no choice. I guess, that's a, yeah, like both, I suppose. Mm-hmm.
Yeah, thank you. Oliver?
Yeah, to Marwan's point about carrier grade nets, I think that has been that issue has been around for quite some time already, and there is currently, just shamelessly plugging one of my own work, there is work going on in the ops area working group currently to make a format which is kind of inspired from geofeeds available to specify prefix length, which also has the possibility to specify carrier grade net within prefixes.
Gianna.
Thank you. I would just want to up level a little bit to say that this is a broader problem. It brought me back to a paper that I read a long time ago from David Clark on attribution in the internet. And I'd highly recommend reading that. I'll post a link to it in the chat for anyone who wants to see it. it's an evolution of the way that the internet has been used. Right? I mean, the way that the internet was designed was quite different. And as we started using it for more and more things, everything became easier, including attacks. And not just attacks, but all kinds of other things that could get eventually misattributed. And so there is a real tension here between attribution for various things, including different levels of needs, like all the way from national security to should you be allowed to watch this movie or not, and so on and so forth. But I think to me, ultimately, all of that comes under a similar thing. One of the things I'd recommend is when we think about GeoIP in particular, or geolocation generally, that we think about the scope of the problem. I think that's that we can reasonably solve using the tools here. Attribution is very simply, for example, something for in the security case, in the national defense case, for example, you can easily do multi-stage attacks where you hack into a bunch of machines in a different country and use those for attacking, and then your GeoIP is completely garbage and bogus. So keeping in mind that the answers that we come up with aren't going to be complete, I think it's useful to think about the things that we can solve reasonably with geolocation.
Thank you. Yeah, thanks for up leveling. I jumped in queue. I think I am next before Jason, if that's okay. I just wanted to briefly respond, Jeff, to your comment about trust and through the proxies and stuff, which I guess is a bit more specific. I totally agree that the state we want to end up in is that we shouldn't have to be trusting the entities that are routing the traffic, let's say through a proxy or a VPN or whatever for privacy. I think, ideally, there would be a way to attribute, or if you need to get geolocation information, whatever, get that in some way, more originally from the client in a way that's not going to be tied just directly to the IP that you're getting here. Because there's so much else that comes along with having a very sticky v4 ISP IP that opens up all sorts of tracking and other properties here. But like the reality is, like, anything that's routing traffic, if you don't want to be blocked in the ecosystem today, you have to provide some sort of signal around the IP geolocation, because that is what the ecosystem has kind of ossified to expect. That it is ossified to expect that IP addresses are tangled up with all of these other properties, and if you don't have some rational representation of them, your traffic is going to get blocked or mishandled in some way. So it's a game that ideally I think a lot of people wouldn't want to have to play, but we're being forced to because there isn't another technical solution to do that. All right, I'll drop my hand. Jason.
Sure, thanks. I keep hearing, just thinking about, today being focused on sort of the challenges, the areas where there's friction. I do keep hearing sort of again and again in the presentations that we sort of have these two problems we're trying to solve historically with IP geolocation, which is where is a person and where is a device on a network. So sort of a person's location versus a network location. And those are solving two very different types of things. And as we transition into discussions maybe tomorrow, maybe we are, going to segment those into two different areas. We've been conflating these two, and a lot of the friction that I hear is, when we're trying to do one with the other, and so on. So that's it. Thanks.
Matthew.
Yeah, sorry, my client's acting up a little bit. Let me know if there's any trouble hearing me. Just a note about CGN and the issue of the loss of granularity or visibility there. I would say CGN is only one of many different things that could aggregate and confuse location. So I could give a few examples, like mobility packet cores or other sorts of things that aggregate a lot of different traffic from all over the place. So CGN is a good example, but not the only one.
Jeff.
I was wondering if there are more Jeffs out there. You meant me, right?
There are other Jeffs, but you're the only Jeff with their hand up, so
that's you. Good one. Look, I'm going to follow up on what you said there, Tommy. And what actually happened about 20 to 30 years ago is we split a symmetric network into client-server. And so there are a bunch of clients and there are a bunch of servers. And then on the server side, we actually got into address scarcity far earlier, oddly enough. And that what we got into were hosting hotels. And we don't talk about the location of a service anymore. And in fact, when you go and buy a web service, your immediate neighbors sharing that IP address are folk you would not want to see in the light of day, let alone in the middle of the night. You know, it's all kinds of people with all kinds of motives sharing that address. And in fact, the location, reputation, and attributes of a server-side IP address are of no help whatsoever to anyone. Yet we still persist on the client side. Now, maybe there's a certain amount of history going on here that, you know, when you're drowning, absolutely anything looks like, you know, a lifeboat, no matter what it is. And I suspect that's what's going on here. Because saying, oh, well, it doesn't work with CGNs, let's rely on V6 to do this instead, which is what I heard from Japan at the end of yesterday, strikes me as just simply deferring the problem, not addressing the problem. And if the problem really is where you are in a political sense or some other sense matters, then trying to rely on a token of forwarding packets to derive that information strikes me as something that we thought about 30 years ago, and we haven't had a better idea since. And we've created an entire industry around a 30-year-old thought. But quite frankly, you're relying on stuff that doesn't actually work very well anymore. And you kind of wonder if location is an attribute of application, not an attribute necessarily of device. Because what is a device now is kind of pretty hairy in all kinds of ways. So the idea in an asymmetric network that only clients have a fixed, reliable, trustable location, client-side addresses, and servers we've given up on, strikes me as a temporary holding place in a longer journey that kind of goes, IP addresses won't do that for you no more. Give up and move on. Thanks.
Yeah, thank you. Just up-leveling one of the things I see, Christopher, from the comments that you made in the chat, and like, because I Jeff, I agree with the perspective you have there, but given the state of the ecosystem and kind of like how much things have ossified to rely on this, one of the things I want to challenge all of us to think about is like, if either there's the thing where this ecosystem needs to be improved or replaced with some other signals, what is the road to get there? Because the world works a very particular way right now, and it's very hard to push against it. And so we need a way to transition. If we think we need to transition, there needs to be a path to do so, and there needs to be incremental steps that are taken here. Yeah, that's just the challenge to all of us. So Nalini and Oliver, are your hands new or are those from previous times? I think they're previous.
Mine's new.
Okay, so Jonna, yours is new, then Christopher, and then we're going to be at break time soon. Thanks for the discussion. Go for it, Jonna.
I want to piggyback on what Tommy said. I think this is actually really useful. So every time you were saying, Jeff, we did this and we did this, and I'm sitting back here going, I didn't do any of the shit. But what I really, I know, no, not just you, but I think that we as a broader community have come together in this room. I think it's a bit of a call to arms there, right? Like, I think this is a moment and an opportunity for us as a community, again, to come together. I think this is a space, geolocation and GeoIP, where we haven't actually historically come together. Pretty much everything that's happened has been organic, has been driven from the ground up by requirements, by business requirements, by businesses that are going online and trying to do what they did, but now on the internet. And everybody in this room has been facing that side of the house. It is an opportunity for us to come together, though, to build something that is more sensible, that is a little more thought out. And yes, it can be architectural. We have the power in this room to come up with something and potentially try to change the way that we do things. But I'm very sympathetic, extremely sympathetic to the idea that we have to start from where we are and have a path to getting to where we want to go.
All right, thank you. Christopher, just the last word before break.
Okay. Yeah. I mean, I love what you're saying about we need to find a road forward. And that's not just a technical question, right? That's a social and business question, right? Because there's all these pressures. What incentivizes people to change their behavior? So this is like a little bit of a shout out about like something that MaxMind has been trying to build out. And I think other data brokers, we would love to like collaborate in figuring out how this can be like a broader thing. But like, I think a path forward, we found a lot of traction with like a platform that is basically built for network operators that is free, that helps network operators like do feedback with us. And this is a really hacky way to do this. I'm going to paste this collateral link in our chat. It's currently like we're working with network operators to have them spin up different geofeeds for some of the metadata kinds of things that we're looking at now. And because these like network operators have pressures that require them to like, they understand the reputation, the geolocation implications, all this stuff by passing this metadata, even though this is a hacky way of like using the existing standard to try and get at some of this information, they're willing to do it. So I think we need to figure out what are the steps, like, because obviously that's not what we want to do forever, is like a bunch of geofeeds per provider or something like that to just like categorize things out. But I think that these are some of the baby steps towards like a better solution. And as the network operators themselves come to understand all the implications of like how their networks are categorized and coded, that provides more like sort of inroads to change how the data is actually used as well. So I don't know, that's one of the things that we're trying to pursue. And I think there's a lot that's like a community initiative. It's not even just like a business initiative. It's like, how do we all work together to do this?
All right, thank you. So thanks all for the great discussion. We're going to have a break now, 10 minutes. So let's come back for people who are aligned to the hour on UTC at 32 minutes after the hour. Please adjust for your time zone. So 10 minutes from now, and we'll get started again talking about some Starlink stuff. Yeah, thank you all, and see you in a bit. Welcome back, everyone. Okay. Great. So for the next chunk of our agenda today, we're going to be doing a couple different talks on Starlink and the use cases there and how that impacts geolocation. So we're going to have first a talk from Nathan, and that'll be 15 minutes, and then we're going to have some clarifying questions, then 2 short talks from Jeff and JPen, and then some discussion on that, and that will take us through the next 40 minutes or so. All right, so Nathan, do you want to go ahead and share your slides? Thank you.
See if this works. All right. So folks probably know what Starlink is. We're a global internet service provider with a constellation of now actually over 9,000 satellites since I wrote this. We provide service to millions of users across over 150 countries and territories, including remote locations, Antarctica, aviation, maritime, etc. We want to ensure that users are routed to the lowest latency endpoints that have region appropriate content for their streaming catalogs and things like that. Users expect to have consistent experiences, maintaining the same media when on a flight or on international waters. I don't believe that there's any standards or any precedent for international waters or Antarctica or polar regions at this time, which can lead to sort of mismatched user expectations and experience. Like, should a US flagged vessel get a US IP? Things like that. We also currently support anycast users, as I've kind of termed it. An aircraft can fly from, example, Qatar to New York and keep the same IP when overflying. And this, if people are using GeoIP for content steering, which seems to be the case at least some of the time, this can result in less than optimal content steering. There's also cases where pop geography aids content steering, where you wouldn't necessarily want to serve a user in Montana from a server in Montana if they are egressing to the internet in Seattle, for example. And this applies obviously to other ISPs, not just Starlink. There are also recent US state laws and internet restrictions that sort of necessitate finer grained state level mapping. But in the same cases above, this could result in less than optimal content steering if GeoIP is used for that. We think GeoIP could convey things like pop location, last mile internet access type, maybe dynamic attributes, international waters, things like that. And we want to be able to optimize traffic based on the network topology and latency rather than physical on-the-ground geography, which makes more sense for our network. And I could imagine this using extensions to existing protocols like ENS0 client subnet or something along those lines. And that's kind of all I've got.
Very fast. Thank you. Clarifying questions. We got plenty of time for that. And we have a couple other talks too. But questions for Nathan. Joe.
So you said that the IP address could stay the same, but not reflecting the changing location might cause, maybe I misunderstood what you were saying. Presumably the way that you reach that IP address is the same regardless of where that aircraft is across the ocean. Or do you
No, the aircraft would actually change which point of presence, and the IP address will be anycasted to many points of presence. So as the plane is flying from, Qatar up to Europe, it might switch to use the Sophia POP for
okay, cool.
For egress, and then London, and then New York, something like that.
Yeah, I kind of want your job now. That sounds good.
Glenn.
And all over the hand. Hey, hi Nathan. Long time no see.
Yeah.
Question. So do you guys allow things like Apple Private Relay to be active? And if so, what kind of behavior does it exhibit when, and sorry, Tom, you don't need to think of Apple. But what kind of, I'm curious how the behavior with the way you guys do the IP address binding, keeping it active as it travels across the globe and stuff like that. How does that interaction work?
As far as I know, we just provide straight internet access, so anything like Apple iCloud Private Relay will work. I don't believe I specifically tested that in this use case. Maybe we should chat with Tommy after the fact and make sure that does work, but I don't see why it wouldn't.
Okay, so I'm guessing that probably means that whatever Apple egress point you were assigned to when you first connected will stay with you as you travel, so that if I'm coming out of the US and I fly across the planet, I'll still come out of a US cluster.
Yeah, I mean, just to clarify there, I mean, the way that we pick egress IPs is just based on what we see the geolocation lookup being of the original client IP. And so it's essentially whatever the Starlink address would have shown up as. It's like whatever mapping that thing has, which is that IP, which it sounds like it's going to be stable during your flight. It's just going to be that. Whatever.
Right, and that's one of the sort of edge cases that we see is like if, pick your favorite airline, Hawaiian Airlines wants to have their geolocation be Hawaii, then sending every user on a Hawaiian Airlines flight to an iCloud Private Relay server in Hawaii is perhaps not ideal.
Yeah.
Okay,
All right.
that by the way, that makes a lot of sense the way you guys both explained it, and it sounds very simple, and that's actually kind of nice in this age of complexity. So there's a simplicity I do like about it, even if it has other issues. I like it.
All right, Sid. Sid, go ahead. Do you have a question? You have your hand up. We can't hear you if you're talking. All right. Not hearing Sid. If you can unmute, go for it. Matthew.
Sorry. Yeah, just a question about how often do you receive troubles related to geolocation, whether that's for accessing content versus performance issues?
Yeah, I didn't actually talk about that part, but if there could be a geolocation problem, we have probably seen it at some point. I think things have gotten better over the last couple years as both we've gotten better about it and other providers have gotten better about ingesting our feeds and doing so more quickly. I don't think I mentioned this, but we do have to like let our IPs sit for a month before we put users on them because the update cadence of providers tends to be, and their customers tends to be much slower than we would like. We also see strange cases of tends to be mostly mobile providers with things like Wi-Fi calling using like the address of the company in the RIR as the geolocation of the prefix. So I think, for example, we had our prefixes registered in South America under like Starlink Chile SPA or something. And so certain mobile providers wouldn't support Wi-Fi calling because they thought the users were in Chile. Some of this usually involves like me or someone finding someone who works for these random telcos on LinkedIn and like hoping that they respond and then figuring out how to work with them. Had the same thing in Europe with like the provider was using the RIPE country code associated with the IP address, which is at least like specifiable on a per prefix basis. So that one's like less of a thing, but if there's something that has a country, people seem to use it for some kind of geolocation, which inevitably results in some kind of problem somewhere if they're not using a geofeed that's updated regularly.
Interesting. Thank you.
Joe and then Caitlin.
Yep. So I just thought I can imagine that if somebody did have a performance problem because they're an Anycast user, as you described them, then it's probably so miraculous and fantastic that they have internet access that's as good as that on a plane or a sailboat or something anyway. It seems to me that they're probably unlikely to complain about an extra 20 milliseconds of RTT because they're being geolocated to the wrong place. So maybe there's a expectation bias there that means you're probably unlikely to get complaints from people who are just overwhelmingly happy.
I think that's probably true. It's also relatively recent. And I think unless you are a real, measurement nerd, you may not even notice at all. Because as you say, it's quite good internet on the plane, regardless of whether you're being steered to, somewhere near or somewhere far. And it's perhaps better than having your streaming catalog change halfway through the flight and the TV show that you were trying to watch, you can't watch anymore.
Yep.
Caitlin?
Yeah, Nathan, I know you mentioned that you've seen over the last 2 years or so that it seems like things have been getting better. Like it sounds like maybe you're seeing some of these problems becoming less prevalent. Do you have any insights on why that might be? I'm just curious what trends you might have seen.
I think we've gotten a bit wiser about how to tackle these issues and keep track of like who uses what provider for what thing and making sure that all the GeoIP providers are updated. We maintain like a giant list internally of like 30 different IP geolocation providers that we have to like check on to make sure that random streaming services in random countries continue to function as we expect when we add new countries to our geofeed and stuff. So we will like add them and let them sit for a month plus and validate against all these things. So I think we've just gotten better at that kind of thing, and hopefully more people are using our geofeed and it's been talked about, and I think there's just kind of more awareness that this kind of thing exists.
So basically relationship building and socialization is what I'm hearing.
To some extent, yeah. And I don't know that we necessarily have a relationship with these providers. We've just kind of found out over the years, like, oh, this thing doesn't work because they use, ipinfo.me or, whatever made up GeoIP provider you want to come up with.
Yeah.
So we've just kind of kept track of that.
Got it. Thank you.
All right. Sid, are you with us again?
Yeah, sorry, I
Great.
had an outage, so
No
I may
worries.
have missed my. So my questions, and I apologize if that's been answered already, Nathan. If you're not going to be changing the IP address geolocation as for, say, Qatar Airways or long distance airlines or ships, what is the application developer guidance for, say, a Hulu developer who wants to make sure streaming services work on consumer smartphones within your airplanes or ships?
I think doing like some of this could be on us if we run our own DNS server. You could use if you're doing DNS-based steering, you could use the DNS server location, since that's likely to be anycast as opposed to the IP location based on eDNS0 client subnet if that's available. And there's ways that you could override that, I guess, and like fake the eDNS0 client subnet data to say that the user's somewhere different than where they are or something. We're not doing that presently, but something like that has come to mind.
Okay. So you're overall, based on what you said on the chat yesterday, you're moving away from changing user terminal IPs and going with
this is
more
just
stable...
specifically on the planes.
Okay. And
today.
as you expand to countries which probably mandate that you do the satellite to ground station downlink as well as internet egress in the same country of licensing, I believe India may have required you to do the country egress into the internet within the territory of the country. Like, is the regime of how you administer IP geolocations, is that going to change? And user terminal assignment is the
I don't think that there's
evolving
any reason to change that based on anything like that.
Okay, thank you. That's all.
All right. Marwan, then Jeff Hughes.
Thanks. Hi, Nathan. You might not be able to say, but I'll ask this question. So you kind of hearing between the lines, it suggests if you're letting IP addresses soak and you're somehow testing them, then internally, I have to hope that no one's doing this by hand, somehow checking to make sure that client IPs are being treated as if they're in the country that you've geofeeded. And so that begs the question: is like, should we be thinking about some version of monitoring or testing or accountability, something, if we're going to go down this route?
It would be nice if there was some kind of automated testing thing. I think someone linked a site that did try to do something like that in the chat yesterday or today. I think we do end up doing some amount of manual checking of things, but I think not all the time. But if there are problems, we now know like who to talk to, kind of thing, or who to wait for it to update or that kind of thing.
Jeff Hughes.
Look, there's been some mention of using eDNS0 client subnet as a proxy for location information in the DNS. I just wanted to add the data point that almost nobody uses your subnet. They use another subnet that geolocates to the same space. And I base this observation on a long-term, large-scale study of the use of client subnet, where I geolocate the end user. I happen to know where they are, and also have the client subnet in their DNS requests, and note that they almost never correlate. There's never the same subnet, but the geolocation is actually accurate. And it kind of strikes me that everyone has actually devised their own form of structural lying in DNS client subnet to give you the same geolocate answer, but not use the actual client subnet. And if there's one thing to come out of this, why don't we actually have location-based DNS tags, we can call them client subnets if you want, that actually locate the user to a known point of locality. And I'm not saying 5 meters, but 100 kilometers would be good, where we sort of forego the fiction that it's a client subnet and simply say, this is a DNS location tag of where the user is to the extent that they want it to be known. That's all. It's just a point of data more than anything else. Thanks.
Thank you. Bob.
Yes. Hi. First of all, I'm a Starlink user. I added a mini to my sailboat. It's really great. My sort of question is, there's, as far as I can tell, there's going to be other similar satellite services coming online in the next years, maybe many. And so this is going to become a common problem for a lot of satellite operators, and it might be good if there was some quote unquote standard way to deal with it, as opposed to everyone figuring it out on their own.
Thank you. Jana, then Warren, and then I think we'll move on.
This is a very question, perhaps, for you, Nathan. Is you said that the POP locations are effectively what's exposed in the IP addresses that come out of Starlink. So for clients that are moving about, for instance, like in Bob's case on the sailboat, do you do anything special there, or is it just basically whatever the POP location is what is exposed as the IP geolocation of the user?
It's a little more than just the POP location. Like if you look at our peering DB versus the IP geofeed, it depends like where, if, we would pick Seattle over Portland for people on the west coast of the US because Seattle is where we have the POP, that sort of thing. And like London as opposed to Edinburgh or something for people in the UK. But we do have people in France who are connected to our UK point of presence, that kind of thing. And they would get French IP addresses. So it's not one-to-one, which is why we published a pops.csv file as well, which is the prefix to POP mapping, which is kind of the network topology side of this, which perhaps people could use or we could standardize or something along those lines. Yeah, I think, sorry, what was the rest of your question there?
No, that was basically it.
For boats, I would say that there's nothing special. It's just kind of based on where you physically are.
It is based on where you physically are?
Well, the IP that you are assigned is based on where you are, based on the IPs that are available in that particular region.
I understand. I mean, I guess I'm trying to understand if you're using anything. Are you using GPS or something else for the for the base station effectively?
No.
Okay. Good enough. Thank you.
All right. Warren.
Yes, I can't remember who made the previous comment about having to announce addresses and let them settle. But sort of an anecdote, for the last many, many years and up until 2 meetings ago, I was part of the IETF NOC, which is a meeting that, or a network that moves around 3 different continents 3 times a year, blah, blah, blah. We publish a geofeed. I just put the link there. And it turns out that a number of large providers, mostly big CDNs, won't actually believe the geofeed file until the network shows up somewhere that seems plausible. So, for example, we're going to be going, Joel just posted a thing. We ship a router to the next location and plug it in and start announcing the address space like a month or 2 beforehand. Both just to like test connectivity, but also to make it so people will believe the geofeed stuff. So a number of, again, mostly large CDNs, it seems like, will read the geofeed file, but won't actually give it any validity until RTT ping similar seems to make some sort of sense. But yeah, I mean, even if we put in a TTL or a similar, people wouldn't believe it because it would seem implausible that, the next meeting's in Shenzhen, but it's being announced from Montreal, wherever we were. So.
Zoltan, very quickly, and then we're going to move on to Jeff's talk. Okay, so you jumped up. All right, and we'll have a bit more time for discussion after this too. Jeff, do you want to go ahead? Oh, sorry.
I thought you wanted me to.
Oh, sorry. Your hand put down. Please go ahead. I didn't see.
Yeah, wrong button. Sorry. So, quick clarification: how does Starlink think about roaming? Like, I buy the service in Bulgaria, it's not available in Egypt, I move to Egypt, I live there, or something like that. Will I get, or should I get an Egypt IP, or should I be able to access content as if I were in Bulgaria?
I believe it's based on where you are in most cases. I think our public FAQ covers that largely, but I don't remember exactly what it says off the top of my head.
The question is partially because I don't think that you have covered all of the countries. At least Egypt is not one of the locations I think Starlink officially serves, but obviously you can go there and roam there and so on. Yeah, I'll look at the FAQ.
Thank you. Okay, Jeff, do you want to go ahead? Share a little bit?
Yeah, just trying to find the right screen. Hopefully I'm sharing that right.
Yes, you are.
Okay, this is a really quick talk. Starlink is kind of unusual insofar as this is the first time I think we've seen large-scale bent pipes. Traditionally, these were things with just mirrors in space. And so you needed to be close to wherever it was that was receiving your signal that was being relayed by satellite. Now, close is weird in a geostationary when it's the same hemisphere, but nevertheless, even the geostationaries had focused beams, and you needed to inhabit, if you will, a point that was sort of mapped by the same satellite. Starlink doesn't do that. It's so close to the ground, 550 kilometers and a bit closer sometimes, that the radius of capture is really quite low, 600 kilometers or so. And so it is infeasible to grid the world with ground stations. And instead, Starlink used these inter-satellite links that their literature claims run at 100 gigs. It's fine up there. It's in outer space. Most countries define how much they own above them that limits it to between 100 and 160 kilometers. Any higher, and no one owns it. And so whatever they do is their business and no one else's. And so they use this relay system where it is quite feasible for the user, the dishy user, and the associated ground station or ground stations, I've noticed in some cases, are actually, half a world apart or longer. It really doesn't matter. You're just following the train of satellites in your signals. The best example of that is that I have direct knowledge of is Mongolia, where they couldn't get permission to actually do a Starlink Earth station in Ulaanbaatar, and instead they actually use inter-satellite links to relay from a ground station, generally in Japan, to actually relay the packets to and from users in Mongolia. Now, in this kind of situation, location is really fascinating because you can think about the location of the dishy, which I'll use as a substitute for the user. There is the location of wherever the POP is, the Gateway Earth Station. And there is also this other issue of where the satellite operator is registered or licensed to operate, because in some cases, they're not the same thing every time. Certain countries certainly have withheld permission for Starlink to operate or are still in the stages of lengthy ongoing negotiations. So in some ways, location is a vexed question. So yes, there is a geolocation map. This is very notional. The attribution of capital cities is kind of approximate, and quite frankly, the way Starlink works, it sings and dances when you're rural and remote. It doesn't sing and dance where you and 10,000 of your closest neighbors, in terms of geographic proximity, are all Starlink users. The service will be absolutely terrible. So that city code is kind of confusing, and the specific nature of the attribution, the capital city of the state, is largely bullshit. And you kind of go, yes, the standard needs it, but no, the standard is of absolutely no use whatsoever beyond even the region is kind of approximate. So the other thing I've noticed is that is not necessarily the the location of the ground station. And it's the notional location of the Starlink subscriber. But if I get Starlink for my car, my caravan, my boat, my thing that moves, then I don't leap IP addresses. As we've just heard, those addresses are anycast into the POPs. And so I will keep my connection as I move around. And the location information appears to be almost an contractual arrangement of where I took the service out, where I bought it from, where I claimed I was at the point where I started being a Starlink subscriber, as distinct from where I am. And all of a sudden then you get this idea that location in the Starlink sense is actually a jurisdictional location, and it has less and less to do with where I happen to be, particularly in roaming. Because if I buy a roaming package, it's the same IP address. And it doesn't seem to move my IP address as I roam. And the question is, well, you know, you can roam and you can roam. There are aircraft that roam and ships that roam, but, you know, I'll get back to that in a second. The next kind of question is that list that Starlink publish accurate? Now, I do an effort of trying to actually map people into countries to find the relative market share of ISPs, and it's based on ad data. And someone pointed out the anomalous situation that was occurring at the time in Yemen, where the Starlink service in Yemen across a 2-month period attracted Starlink users 300,000 ads, lucky Starlink users, whereas the dominant ISP in Yemen, YemenNet, had only half that number. And if you make the guess, and it is a guess, that ads equals users equals market share, then it was certainly interesting that Starlink was having 60% of market share of Yemen. That's bullshit. It's actually that Yemen blocks ads. The lowdown scum. How dare they block Google ads? And it was distorting the numbers. But nevertheless, you know, it raises a question about what's going on in terms of geolocation in Starlink. Because even if you account for Yemen getting an underproportion of ads, Starlink still has a healthy amount of users in Yemen, a couple of million. But I don't get a discount from Starlink retail services because I happen to live in a country where the GDP per capita is $750. In other words, this service is unaffordable. Yet there are a huge number of users in Yemen in a country that's struggling. And there are a number of kind of questions around this that are interesting about geolocation and usage. Starlink measure subscriptions. I measure users. So if I feed a Starlink service into a community Wi-Fi network, as long as I keep within the rules in Starlink's T's and C's, I can do that perfectly fine. But then the number of users and the number of subscriptions start to vary dramatically, which is one possible explanation of why Yemen has so many Google ads on their Starlink service. Other countries have gone all the way, actually purchased a Starlink ground station and actually set up a community agreement where the ISP itself is actually upstreamed by Starlink. And we've seen that in a couple of Pacific nations, and I think some area of remote Canada have gone that way. But just doing it yourself doesn't contravene any particular terms and conditions. Everyone consults the Starlink map, the map of countries where Starlink is available and not available. And if you look at the geo feed, you find 2 countries, Sudan and Myanmar, where Starlink is not available. Yet the geo maps them. So there are a number of IP addresses that map into the Sudan and map into Myanmar. The question is, there are an awful lot of ads being placed into both Myanmar and Sudan, into countries where Starlink does not sell. And you kind of wonder, when there are 2 anomalies in a large table of data, how reliable is the rest of the table? Is this Starlink being pragmatic and saying, look, I know where the dishes are. I can probably locate them within an accuracy of a few meters because the dishy probably does its own GPS locationing. Fine. It's in the Sudan. We all agree on that. We don't sell in the Sudan. Someone must have moved the dish there, but, you know, we will give attribution to the Sudan. A lot of ads get placed into the Sudan. Same situation in Myanmar. It seems that Starlink is used a lot in countries where there is civil unrest because it's the one thing that works. That's the case in Yemen, and it's certainly the case in Myanmar, where the local ISP is under the control of, you know, one of the two of the, you know, competing parties, and, you know, life on the ground is absolutely chaotic. Starlink offers you a way to beam out, but it's also abusable. There are stories in Myanmar of Starlink being used by scam centers and actually just sitting there in Myanmar, almost immune from normal conventional reach of jurisdictions trying to prosecute them. So it's hard to tell when you see two quite visible anomalies in the Starlink geoloc data, how reliable the rest of the data is. And these are the top 20 countries on this table.
Just quick time check.
Usage. Sorry?
Time check that we should.
Yeah, I'm about 2 slides away. Aircraft. It's an interesting law, but as soon as your wheels go up and you've left the land under the Tokyo Convention, you are subject to the laws of the country of the registration of the plane. So it doesn't matter where the aircraft is a piece of extraterritorial sort of territory of that craft in flight, irrespective of its position. It's similar for ships at sea, but the UN Convention says you've got to leave territorial waters physically and be in international waters before it becomes the country of the flag. Should ships at sea and aircraft revert to that country of registration for geoloc, in which case, how fast is geoloc in trying to track that? If I take off from Dubai in a US flagged aircraft and land in London, which country am I in geoloc wise while the plane is in flight? Done.
All right. Thank you. All right. So the next up, we also have a quick talk from Japan. Share.
So can you see my slides?
Your audio is a bit compressed sounding.
Okay.
For me.
Okay, I'll try to be close to the microphone. No.
And we don't have too much time for this, so I know you have a lot of content on your slides, so let's try to go through quickly though. Thank you.
Yeah, so I will be quick. I think by now we all know the importance of accurate geolocation, and GeoFeed might be the best available right now. And this is a case study we have been doing for more than a year on Starlink ISP. And you may wonder why we picked Starlink, because they are the fastest growth company right now. They shuffle a lot of IP addresses, and they also acquire a lot of IP addresses as well. And also, like, a user can move very quickly by airplane or even boat. So there's quite many problems with how the GeoFeed is managed in and out. For example, like in many places, GeoFeed is still manual process. Some engineers just add the things by hand. And there's also no similarity consistency among geo IP. And some countries will be the whole country like one geo IP, and some countries they have subdivided into smaller regions. And this, of course, will be amplified by the frequent address changes and user move. Geo IP is the only problem because people also rely on DNS as well for geolocation purpose. But the DNS is another animal because it's cached everywhere. So sometimes it's very hard to update and propagate it quick enough. There's some examples here. We can come back if you need. So of course, from the users, there are complaints. So you've seen local complaints thousands of miles away, and we have a dish inside the Arctic Circle is geo IP to the city of Vancouver, which is more than 2,000 kilometers away. Even geo providers provide the perfect location about the IP address. it's up to the content providers how to use it. So for example, like if you take an airplane from Victoria to Toronto for the airlines, and Ookla is going to use a speed test server near Toronto because that's where Port Airlines is headquartered. And the Cloudflare and Google, they're going to use like a Denver because that's, let's say, the buyer set, which means like they are close to the exact point of the user. So which one's better? It's arguable. So this is something like we believe, like what IETF or IAB should do. Essentially, like geofeed should be timestamped on the TTL, same as like we have with DNS, because this could be cached somewhere. And also, like we should provide some guideline on how to, let's say, define the geofeed granularity, and also provide feedback, like guidance to the content provider how to use it properly. The same thing like for the geo IP, the signal providers. We have a couple of like providers on the call right now. I noticed like we are probably the only team from the university in this workshop. So this is how I encourage my colleagues to, let's say, interact more with IETF and industry, because like there's also like some issues could be involved as well. So far is everything like I presented some geo IP providers in September before the submission to the workshop. So this is some update after like the workshop is announced. So there's a few things changed at Starlink. Thanks for taking for the feedback. So one is like now Starlink like also publish the pop location in addition to the geo like the IP location for the client. Now they also show like where the exit of the user is. We also maintain a website basically archiving the Starlink geo IP and the pop, let's say, feeds, and also compare between them to see how consistent they are. So far, about 30% of the IP address purchased are not consistent with each other. So that's why a lot of things can be like improved as well. And also there's some new initiatives. For example, like Starlink started to do like a per state geo IP in the United States. But so far, like those IP addresses haven't been in use yet for both IPv6 and IPv4 gradually. Some people ask about starting their own airplane. So this is like what mostly like recently confirmed. For example, like for people like take Qatar Airways from Montreal to Doha, you can see like your geo IP will be at one single location in Doha, but your POP is going to traverse this list of like POPs along the way. So of course, like this also create a problem about inconsistency between the like geo IP and the POP locations. This might be intentional, but this also has some implication as well because it's introduced more dynamics in this mapping as well. I don't know whether we have any people from like Ookla like on the call as well. Just I mentioned like Ookla try to use the geo IP location of the client to do speed test. This of course is good for the terrestrial service providers because the user location, the POP location are close enough. But for satellite and also for some mobile operators, the user location could be very far away from POP location. So what we measure may or may not be like what the user experience in that sense. And there's also many tools available. I think I should like thank the Rep Atlas people. They provide like such a platform for us to do a lot of measurement on Starlink and other like service providers as well. So this example show like a translated behavior of a user when people put the Starlink as the backup or failover or load balancing. So normally use like terrestrial network, and then for some duration you jump to like Starlink. So you see the like delay jump. And then let's say they go back either load balancing or failover like covers. Most recently, they have a new GUI, which is like really good for us to let's say analyze the performance and also like the behavior of let's say those trace log and the GRP as well. So I think like we need let's say community effort to handle this type of things because this involves network providers, involves like geo IP providers, and also involve like content providers as well. So the goal is to make sure like the user can really like consume local content if they want. That's my presentation.
All right. Thank you very much. Thank you for being quick on that too, and appreciate you.
I try to be in 5 minutes, so that's why I have a stopwatch here as well.
Amazing. Thank you.
Be on time. You cannot like go over like your lecture hours.
All right. So we already had some questions and discussions that we gave a bit more time to earlier after Nathan's talk, but if there are any particular questions or things people want to discuss on this topic, based on what Jeff, Japan were saying, please raise your hand and we can give another couple minutes to that. Joe.
I think this is interesting because I think Starlink is a obvious and familiar example of something that feels different. But I don't think it is that different, because I think we also see a lot of the same problems in users that are jumping between VPNs and IPv4 blocks that are leased to different people in different places. The speeds are different and the frequency of change are different, but the fundamental problems are the same, that these addresses are mobile and the locations are not fixed identifiers. So I think it's a really good example, but I think if anybody's thinking that these are just Starlink attributes and it doesn't apply to anything else, I'm not sure that's true.
Yes, we pick Starlink as an extreme case. We want to show that like a cause of the problem. Of course, like this same thing could apply to other places as well.
Robert?
I wonder how Richard's bank site would work or not work depending on where he is in the air, and sometimes he can make a transaction, sometimes he can't. That's actually quite fascinating. A different one is that I don't know if that's true for Starlink, but I just wonder what the effect of like happy eyeballs would be. Like sometimes I'm on V4, sometimes I'm on V6, and depending on where those are geolocated, I might just jump countries in 2 milliseconds. No, 300 milliseconds, sorry. I don't know if Starlink does V6 and if they do the same way. Yes, happy eyeballs indeed.
We do IPv6, full native IPv6, and we try and keep the geolocations the same.
Right. Geo-confused eyeballs. Yes, thank you, Carlos. That's it.
Yeah.
All right. Thanks, Robert. Jeff?
Yeah, in response to Joe, this is an increasingly common situation, and certainly if the dreams of the number of folk launching massive constellations come true, it'll be even more common. That's certainly true. But I think it's incorrect to think that mobile is the dominant use here. I actually think it's a way out of poor infrastructure in a whole bunch of underserved locations. And in this case, you have to remember what Starlink's trying to do. What Starlink is trying to do is to say, you can use us as a plug replacement for a local terrestrial ISP. So the experience, if I'm located at a fixed location in a country, should be the same as if I bought out, a fixed line service or even a mobile service at my location. And so to make that sort of plug-in replacement and make the user experience the same, then I can quite, applaud Starlink doing a lot of effort to say, I'm a user of a dishy in this location, in this country, and effectively saying to all the service providers, treat me the same as all the other folk in this country who are served by other ISPs. The real question comes, how do you handle mobility in location? And that comes to an issue of in places where countries are small, Europe, and mobility across countries is really easy, a train ride, then that becomes an interesting question. What Europe tried to do was solve it the other way, trying to reduce territorial distinctions and saying, well, if you're in Europe, you're a European, treat everyone the same. But I suspect that kind of solution doesn't really work that well either in many other places. And so mobility remains this issue with a lot of mobile providers that cover jurisdictions. And quite frankly, the distribution mechanism we used with geofeeds is only marginally better than chiseling the lat long on a block of granite and moving the granite around, because it's completely unresponsive, it's as slow as all hell, and doesn't work very well. And if you really want to track mobility, this is the wrong place and the wrong way to do it. Yeah.
Thank you. Jana, last word, and then we're going to move on.
I was actually going to echo something that Jeff said. I think this is The broader problem here is one of mobility, and it's not just Starlink, therefore. It's going to be cellular providers. We know that cellular providers are notorious for having bad geolocation. And this problem, even though not represented in this particular forum right now, I think is an important problem for us to think about. That's all I want to say. Thanks.
All right. Thank you all. So next up, we have one last talk today on privacy impacts. Divyank, do you want to start sharing? And we'll give 15 minutes for this in total. So we'll go, 15 minutes from now, 10 minutes of presentation, 5 minutes of questions, and then we're going to go into our list gathering exercise at the end.
Hello. Hi, everyone. Gurshadbhat is going to get us started. Just want to confirm if you can see my slides.
Yes, we can.
Great. Thanks so much. It's after midnight here, but I'm sufficiently caffeinated, so
thank you.
Hope to be. Divyank and I work at the Internet Research Lab, and we primarily study network security and privacy properties, particularly on how vulnerabilities are used for surveillance, privacy abuses, and censorship. So we're going to speak from that perspective a bit, and also hope to shed a bit of light on what end users face and expect, particularly on IP geolocation. Next slide, please. And just to ground ourselves, because we're in such a specific conversation about how IP addresses are used for geolocation, is that the original purpose of IP addresses, as we all know, is routing, pure and simple. And we should be aware, therefore, that IP geolocation, next slide, please, is in a whole suite of uses, most of which were perhaps not intended to be uses as such when IP was designed. And some of these uses may seem entirely acceptable to everyone, complying with laws, localization, etc., IP reputation systems. But all of these, we think, can be legitimately classified as function creep of some sorts. Next slide, please. So what is perhaps concerning about IP geolocation is that IP is or in some, phrased differently, IP addresses can be categorized as personally identifiable information. And we may know that technically in certain situations, but it's also being seen by the law as such. And this is recital 30, for instance, from the European General Data Protection Regulation, GDPR, which has had some discussion about how IP addresses qualify here in terms of online identifiers. And next slide, please. And another example from Canada. I think this is from the Data Protection Commissioner's Office, where IP addresses are specifically discussed as a PII. And just to add here that at IRL, etc., we've participated in many internet measurement projects for research and creation of resources by nonprofits, where we've done these impact studies and tried to do our best to remove IP addresses from our data sets, because we consider the worst case where IP is PII, it can be collated with other resources to be PII even if it's not, and it can be a matter of actual freedom or not for some high-risk individuals. Next slide, please. But even when it comes to the general internet user, they do treat IP addresses, even if they can't name it specifically, as personal, and perhaps don't find all uses of IP addresses as palatable to them. We do have some evidence now, not just quantitatively from the increasing use of VPN, Tor, etc., but also qualitative evidence for why they are switching to VPN, Tor, etc. And this survey from 2022 asked individuals and found that the top 3 reasons for using VPNs were actually for enhanced security, privacy, and to bypass censorship. As we're going to see, they're actually quite closely linked to IP geolocation, these issues. So in some ways, it is great that work at ITF recognizes this, through OHI and MASK, etc. But it's also important to not lose of this sight of this evidence when we discuss things like geolocation hint and how they're designed, which I know we'll discuss tomorrow. But next slide, please. Now, just to add the two aspects that we just discussed. First, IP addresses were not meant for IP geolocation. Second, IP addresses are PII. And the third aspect, very important to understand why this is privacy abuse. The primary reason is that it's a use/abuse that happens without user consent in most cases, and in all cases, frankly. And to tie this to the legal aspect, and not just empirically in the jurisdictions we saw, but even most, the oldest, the newest, all frameworks about privacy and data protection place consent and autonomy as one of the core principles. And this is also true for the most widely accepted framework, which is the OECD principles, for instance. And again, this is, lots of the community knows this in principle, that things like this are privacy abuse. And this is a direct quote from RFC 6973, which is on including privacy considerations in specifications. And it's worth stating again in full. Data collection and use that happen in secret without the individual's knowledge are apt to violate the individual's expectation of privacy and may create incentives for misuse of data. And so I think it's time to accept that IP geolocation doesn't meet the standard that the IETF and lots of us are seeking to set for ourselves, honestly. And if we do think the internet should serve end users, we need to move away from it gradually. And so it's great that we're finally having this conversation. I'll hand over to my colleague Divyang to discuss some other abuses of IP geolocation and perhaps some ways to address this in the future.
Thank you, Gushapad. Hi, everyone. Yeah, so this slide shows, I think, the pricing chart for a popular geolocation provider. And you can sort of see here that increased accuracy of geolocating individuals is sort of a selling point for these services. I think this is a popular service, so they probably don't do any sort of data mining. But it is not hard to imagine a data broker that does extensively profile internet users to more and more accurately geolocate users. So for example, if I wanted a really accurate geolocation of a user, I could go to a weather app who my phone pings every 2 seconds with my exact GPS coordinates and my IP address, and they would have a fairly rich estimate of exactly where I'm located at any point. And this sort of non-consensual framework of geolocation sort of incentivizes this behavior. Another thing which sort of motivated mine and Goshabad's work in this area is the increasing use of IP geolocation as a vector for censorship. I know that there are often presentations at the IETF about DNS blocking and the use of SNI for content filtering at the network layer. But what we're actually seeing on the ground is that a lot, predominantly censorship is happening in some places through geo-blocking, which relies on IP geolocation. In India, for example, in 2022, we got some data out from the IT ministry. They blocked around 7,000 pieces of content that year. And about 50% of these were social media posts on X, and 25% were on Facebook. So with the centralization of the internet to a few platforms and a lot of content being hosted on these platforms, there's too much, I guess, disincentive for governments to block the entire website. So they use IP geolocation to block individual pieces of content on these sites. And the social media platforms in turn use IP geolocation to enact this censorship. I also wanted to talk a little bit about compliance and consent. So these are some examples that I've cherry-picked to illustrate how business obligations can sometimes be at odds with consensual geolocation. So the content licensing agreements that pretty much every streaming company has these days, it sort of requires coercion. They don't want users to be able to consensually opt out or not share their location. So in a case like this, like having their access to their geolocation without their consent is actually a feature and not a bug. And another case that I noticed, this was actually on the GitHub issues for the advanced IP protection that's coming to Google Chrome. Like this group, while adding privacy to IP addresses, they noticed that some of the privacy unfriendly properties of IP addresses like geolocation don't work. And on that issue, they were discussing the use cases for IP addresses, and someone commented that, hey, we need this for GDPR compliance. Now, this was baffling to me that you actually needed to infringe on someone's privacy and geolocate them to comply with the privacy regulation. But it turns out what they really wanted to do was minimize their compliance. So they only, if a user is located in the EU, they only want that user to get the privacy protections afforded to EU citizens. And yeah, if they wanted to comply with the spirit of the law and not just the letter of the law, I could imagine them coming up with sort of a superset of all privacy regulations across the world and giving all users the benefit of all of them. But this is actually done to minimize the privacy given to a user. So it's not really complying, it's not really for privacy. So there are cases like this where this sort of business logic overrides the interests of internet users. And yeah, I think something that came up over the past few days is that there's two sort of distinct categories where geolocation falls. There are some use cases that need to detect the geographical location, whereas others want to sort of detect the topographical location of the device or the infrastructure in the network topology. I do think that the latter use case falls more into the realm of routing. We are dealing with the core routing protocols of the internet here. But the former use case, that is geographically locating users, falls more into the application layer, I would think. This is business logic that each application needs to enact separately on its own, and I think it should be dealt with at that layer. We have already seen sort of good examples of this come up in web browsers and mobile OSs where the user's consent is taken for accessing the geographical location. There is also some amount of coercion in this aspect as well, but it's better than not taking consent at all. And yeah, so as IP privacy solutions sort of make their way into the IETF, I think it's a good time to sort of reconcile with consensual geolocation and how we should go forward. And yeah, I just wanted to end with a short reflection. Gushabad and I are both censorship researchers, and the history of protocols at the IETF demonstrates this sort of clear pattern to us, where there's network layer metadata that's leaking private information. Pretty much the entire internet will go and design solutions based on the free availability of such metadata. The metadata is exploited to conduct privacy violations and large-scale censorship. And then finally, companies are forced to reevaluate this dependence once these signals are no longer available to them. So this is something that we clearly saw with plain text HTTP and DNS, and more recently with SNI. And to me, IP geolocation appears to be a similar situation. And I think this technical debt is just going to keep compounding unless we deal with it sooner rather than later. Yeah, I think that's all I had.
All right, thank you both for sharing. So let's have a chunk of time now for discussion and questions. Let's aim to, let's say within like 8 minutes, move on to our kind of last exercise of gathering the list. Matthew, go ahead.
Yeah, thanks for the talk there. I will say one interesting thing I put in chat there for those who are interested. The Canadian Supreme Court made a ruling about the treatment of IP addresses. And I think it's a little bit technologically confused, their ruling, but that's an aside. What I wanted to focus my comments on here is the distinctions between different similar attributes that show up in geofeeds. So in the case of the US, zip codes are, there's 100,000 of them for the entire continental US, plus Alaska and Hawaii. In Canada, we have like 3 letters and 3 numbers. So you could have like 100 or 17 million, I think, combinations of different postal codes and a much smaller population. So in some cases, I know our postal codes can go down to the specificity of like 2 houses could be in one postal code. So we are cognizant of the privacy concerns that you're talking about here. In our case, we do obscure that level of specificity. So just a note for the standards as we think about that, though, we may want to think about those similar attributes like postal code may have different degrees of specificity that we should be masking. Thanks.
I had jumped in queues just as an individual here. I had a thought when you were bringing up the point around censorship of blocking the content, the server blocking clients based on where they're coming from. So overall, I totally agree that it's much easier to defend the privacy of things when it's based on consent and it's not hidden, and like having the IP location be something that the user is not aware of, that they cannot control disclosure on, may or may not be accurate, problematic from a privacy angle for sure. But I imagine like if we figure out ways to get away from that, if the content provider is sufficiently motivated to say, I must block this content for people in a particular region, it feels like then their stance has to be that they will block the content unless people prove they are not in the region that is being blocked. As it was mentioned on the chat, maybe that requires oversharing GPS location. But even if we have good solutions for just sharing, hey, here's the country I'm in some attestable way, I'm curious if you see any way in what you're discussing to avoid this problem. Like it seems like we can make IP geolocation privacy better, but there's not really a great way to solve people blocking content unless they can prove where you are. Like that seems like that can change, but it's not going to go away. Curious to hear a response on that.
Your response or any response?
I would be curious from the presenters, but then also other folks too.
Maybe I can take a quick stab, and Divyang, please add to this. I think you're absolutely right that again, this censorship is also happening under like to comply with regulations or like some IP stuff on the side. It is going to happen in some other way. Is exactly right. I think the fact of mentioning is that it's like a compounding problem, and that it's first, IP geolocation is happening without consent. Second, this non-consensual collection of data is being used for, I mean, in both privacy and like censorship use cases are for like human rights abuses in like lots of parts of the world. So and fully agree that those other solutions are not perfect. We need better user agency to control like granularity of information. I think, but not in terms of legal compliance. We have seen companies only using the signals of location legitimately when it's required, right? Like for instance, you can't easily switch countries. Let's say I downloaded the Facebook app from the Indian Play Store or App Store. It like even if I spend 6 months in the US, it's not going to think suddenly that like I'm in the US, right? Like so, it's using other signals too for compliance and other purposes. So IP geolocation is also not the only signal in this chain, but it's one of those that is happening truly without consent in apart from all of the other factors.
Okay.
So you're right that
we're
it's
on the
going to
same page
happen. We shouldn't be. We should plug the one that's non-consensual for sure, right?
Yeah. Okay. Thank you. The other Tommy, please go ahead.
Thanks for the presentation. It is really interesting, and I guess I have some curiosity coming from a network operator perspective of, hey, you are using this IP address, but it's not yours. I'm the one who it's registered to. I'm the one who's responsible for managing it. And traditionally, users are really terrible about managing their network resources in general. So what would you say would be are you advocating for the end user being able to publish their own geofeed and that override what I, as the network administrator, am saying? Or are you saying that I, as the network administrator, just need to keep in mind the privacy of my customers and say, okay, well, I'm not going to use a zip code that can identify my two customers, or even, I know I only have the one customer in this zip code, so therefore, okay, I'm going to use something a little bit more. I need to be a good network administrator and use my brain and be considerate of the privacy of my customers and have something that is more generalized, but still meets the needs of my customers, which is that they can access things that the rights holders have the ability to say, I don't want them to, or I want them to be able to access.
Even if the user is seen as leasing network infrastructure, and it is, I mean, not just in principle, but also legally, the privacy data protection obligations don't go away, right? And if you are able to conclude that, so when I'm using the internet, I actually don't know whether my network operator knows that I'm perhaps the only one in a block or something. But if like others around me are on a different ISP, how specifically can I be geolocated? So this is still non-consensual use, and yes, like I think network operators should. And Jaya made an interesting point in the chat about like collection versus use, right? And I think both are seen in privacy. It's not that you collect something and you can use it for purposes that you haven't mentioned to the person, right? So the obligations in terms of data minimization are both, like it's more commonly intuitively known for collection, but we should be seeing it as applying to use as well, right? And not keeping or selling that information, for instance.
Thank you. Marwan.
Thanks. This was an interesting presentation. I have lots to say about all of the other topics, but there was one. I'll focus on one. You put up a little table, and I think this comes back to Matt's comment about zip code, postal code. I'm almost embarrassed that I certainly haven't raised this before, and maybe we as a community. There is a question of, should we be asking what we're willing to tolerate in any standard or convention going forward? Because I've got to be honest, with very rare exception, and I love my IPGeo friends, you all know this, the idea that you would narrow down an IPGeo to a zip code or a street or some attempt at a latitude longitude, like I feel like maybe it's worth identifying the use cases that require that kind of breakdown. I mean, everything I've heard so far says at best city level is the granularity that's required. Then if we're going to pursue a solution, maybe we want to think about what we agree should not go into this, into the, feeds or whatever it happens to be.
Thank you.
Yeah.
Christopher. Or sorry, if you want to respond. Different. Please go ahead.
Yeah, I do think some of the standards do mention a granularity, but the thing is we can't really control that even if the standard specifies it. This sort of non-consensual location sharing does sort of open that whole can of worms and incentivize people to do creepier things than you intend them to do.
All right, Christopher?
Yeah, I'm so glad that this topic was raised, even though it might sound like why would I be glad? Because we're obviously selling this data. But it's such a complicated space where I feel like we're talking about that this data can be used to promote censorship. I understand that there are potentially negative implications for the data's use. One of the things that I think about when that is raised is that increasingly it seems like governments and industry are saying we are going to implement, policies that require us to understand where people are. And of the breadth of kinds of data that's out there, I think IP geolocation data is one. It can be very precise in a way that is way more invasive, but when it is handled properly, when you have a data broker who's like properly engaged with the regulations, who understands them, there are a lot of things you can do to make sure that it would never identify like an individual person. Now, I understand that you're talking about consent as like an underlying thing, and that's still being violated in a sense just by associating location with an IP address. But I don't see that what we can do will stop governments from wanting to censor and stop industry from wanting to sort of enforce geofencing and things like this. So that's one of the places where I'm thinking. The other thing that you raised about like the postal granularity, I 100% agree. Like MaxMind is in the process of rethinking under what circumstances. I mean, often this data is really bad at the postal level anyway. It's not very good for many IP addresses unless you're leveraging other signals, like the kinds of things that, our colleague from GeoComply was mentioning the other day, right? Like with the data methods that peer brokers to MaxMind use, I don't think we're really getting down to postal level granularity with much like precision anyway. And we expose that, but it's only in our premium products that we expose like the confidence in a location. So that's sort of a shortcoming if people aren't using the premium products, right? But I think one of the key things is just like the proper engagement with the regulations, the proper and concern for privacy is a key piece of what data brokers need to be doing, both to protect, not just to protect themselves, but to protect the public and like the people who are consuming our data. Because if we aren't complying with the law, and if we are playing fast and loose with it, moving into gray areas, that's a space where that puts our customers at risk as much as anybody else, and the public, and fundamentally MaxMind. I know that internally we invest a lot of time and have a lot of values around protecting privacy. So, I mean, I don't think that we could all imagine a world where IP geolocation goes away for this kind of a thing and MaxMind goes away for some reason. But I don't think we're like seeing that world in the 5 to 10 year future. And in the world that we live in, I feel like this is a better form of location data to sort of be utilizing for these purposes. So I don't know, I'm wondering like what your thoughts are around that, given the other kinds of, like we've seen governments put in huge infrastructure to try and, sort of take this in hand themselves. So I don't know, how do you feel about the kind of practical considerations of that?
Cool. And just time checking us here. We have 4 more people in the queue, so let's go very quickly.
Yeah, I can try to quickly respond to that. It's a common argument that people will resort to more restrictive means in response to like protocols that block censorship. So, for example, when encrypted DNS and SNI were first deployed, there was this proposal in Kazakhstan that everyone would be mandated to install a root CA in their browser, so that the government could use that to detect their internet activity and block it. So yeah, there's always this risk of escalation where you take away one method and they rely on a method that leaves the user worse off. But I do think we have to go down that road and try to block every sort of gap that's available to them. And we see how it goes.
If I may just quickly add, I think you're absolutely right. Governments who want to censor and surveil will do that, but as network engineers who care about user privacy, we should also try and do our job, right? And like also try to plug those gaps. And I'm glad you mentioned the 5-year time frame, because like a workshop like this exactly helps with this purpose. As we said, like providing your GPS location is obviously not the best thing, like so the W3C API or like how mobile OSs do it, but yeah, at least they provide us with a consensual framework, and we've increasingly seen them add, iOS has this like precise location or like coarse location, and I think people do care about this, as we saw also from the survey results, and we should sort of follow the user patterns we're seeing and design those options where we can. I mean, the ideal scenario, as we can all imagine, is like I am offered by an application, and my system provides me with the option to say, I just want to share my country, I just want to share my city, or I just want to. I mean, if it's food delivery, I probably want to share my address. So things like those.
All right. Nalini, then Rob, then Glenn, then John, then we're done with this.
Sure. Yeah. So guys, I'm very sympathetic to what you guys are saying. And on behalf of somebody who would be an application or an industry who would wish to behave well and get said consent, I think at least a portion of this we may be able to solve if you think of something like a certificate. You know what I mean? It's like let's say I'm a bank, I give you the app, you download the app, and within the app I ask you, I say, I wish to prevent fraud. Are you okay with me geolocating you to whatever specificity that you're good with? And then maybe we have something like a certificate authority, something like that, or something where you register and then the geolocators, they check that. But I mean, we would have to design some kind of system. But I think, isn't that kind of what we're in the business of doing? But I don't know what your thoughts are about that.
I'm gonna have us just go through getting people say in rather than having the full discussion, and we can have it more on this too. But thank you, Rob.
So briefly on the subject of consent, you can't really have consent without having informed consent. And consent from, I'm going to pick on a couple of people here that I know well, Joe or Lee or me, is not the same thing as consent from my 87-year-old mother, who has no idea what she's clicking through on when she goes to a website that says, we use cookies here because GDPR. Now everybody gets the same, high level of protection. And that has been reduced to the level of a California Proposition 65 warning, where the coffee that I drink has a warning on it that may be hazardous to my health. And so I want to remind everybody that we are the 0.00001% of understanding what we are dealing with here. And it must be, any kind of request for consent can't be just a click here to say, yes, it's okay to do this thing, and the user has no idea what it is they're consenting to. Thank you.
Yeah, thank you. Glenn, then John.
Yeah, thanks for the presentation. I'm a little confused on the censorship use case. How a user's IP address is involved there, because if it's DNS blocking, it's not inspecting the user's IP address, it's just the DNS server refusing to return answers. Likewise, for IP-based blocking, it's the network saying, I won't let traffic go to this IP address. And so I'm not understanding the IP location and the privacy intersection from the user perspective for the censorship aspect.
I can maybe comment on this one a little bit if it helps. So, Glenn, you can imagine we agree that most network versions of blocking have no transparency whatsoever. Connection fails, DNS query fails, the user has no idea, is my ISP broken, is my browser broken, whatever. So that is, I think, the terrible world. You can imagine an operator in a region has to be compliant with whatever laws, whether we agree with the laws or not. As much as I have lots to say about this, you can imagine a server, in order to be compliant, would see a connection coming in from what it believes to be a place, and says, we need to comply with the law. This is not available in your region or to you. Ideally, that goes along with information about where to go or who to complain to and so on and why. And so at least it gives the user some agency. But at a minimum, the server being able to notify the user raises the level of transparency in the game. However, so I think that's what we're talking about.
Okay, so I'll just pick the one comment. I think we need to be very careful to draw the fine line between what is sort of censorship at one level, but then the other part is contractual geo-filtering that is done by the person who's provided the data, and it's their choice to do that filtering. Okay, that's all I had to say. Thanks.
All right.
Yeah,
John,
I'll just add that the latter also uses network level metadata to enact that compliance. So that's also where these protocols come in.
John, are you done? Yeah.
I first want to thank Divyank and Goshawa for presenting this. I think this is a very important perspective. We have to think very carefully when we go into developing mechanisms and protocols that are going to be potentially used and abused by all kinds of people. We should think carefully about how to square away the concerns that are being brought up here. That said, I think this is a hard problem. One of the things is that there are discoverable things in the network. Making them private doesn't make them undiscoverable. Whether it's, if your location might be private, but if you're shouting from a place and I can know which direction you're shouting from, I know where you are. And, no law can prevent that from getting used in some way or the other. So to some extent, I don't want to over-rotate on the legal aspects of this because laws change to meet practice. But I think we have an opportunity to sort of help understand how to define meaningful practice going forward.
All right, thank you. Okay, so don't have a lot of time left, but I'm still gonna do this exercise. I'm going to be sharing my screen here. This is our little Hedgetalk notes. I'm going to drop the link in the chat for people, so you all can see this. Great. So, just wanted to gather kind of like from what we were hearing today, just get people to share all the different gaps and problems they've heard from the different perspectives. Maybe people, if we just want to rattle off things here. So just raise your hand and then just give me a sentence to type in. And also people can go in and edit themselves too after this. So I can start here. I heard, early on there was about the consistency of names, characters, typos, etc. In GeoFeeds. Other things that we heard today. Raise hands. Shout them out. Eric.
I think one that's coming up is being able to capture granularity in GeoFeed, such as capturing what things that are anycast or country scoped and possibly also along with that like endpoint type.
Okay. Jenna.
Two things. One was on the TTL or publication time of GeoFeeds. The second one is broadly what we just talked about, which is user intent or consent in IP use of IP geolocation.
Yeah. Okay. Christopher, I'm assuming your hand is up from before, but if you want to say something, go for it. Joe.
So I think there are two things. One of them is the identifying the particular people who've made edits and corrections to particular mappings from the source to the consumer.
Okay.
This relates to our our ability to support our customers who want us to complain about something. And the other one was the array of different questions and answers, and the fact that you can't tell from just looking at the mapping what answer maps to what question.
Yeah. Yeah. Okay. Asked or answered. Sid.
So I think fitness for purpose, as defined by, say, is this useful for language localization? Is this useful for a banking regulation check with the banking regulator of a country? Is this useful for CDN routing, video processing, pop selection?
Yeah.
These are all orthogonal purposes. And as we've discussed in the past 2 days, they are wildly different, and maybe we need an enum data type for this.
Cool. Thank you. Drew.
Yes. So for me, I think the point about infrastructure geolocation being different from the user geolocation and the way we handle that difference is important. One more thing that comes to me is I think the idea of the geolocation being the only source of truth. Like, how do we add the idea of uncertainty or the percentage thing from the day one? In some ways, if you can frame that. The third thing that comes to mind was, which was from today, was we sometimes try to use IP reputation and IP geolocation in the same breath, and we need to differentiate between the two.
Yeah. Okay, Tommy.
Something, and we've kind of touched on it so far with these points, but the use of this IP, is this a server versus a CGNAT, etc.? And then also in the something that was brought up is that a IP can be have multiple true locations. As well with the Anycast. We kind of touched this a little bit, but having the ability to have multiple locations is true.
Yep, for sure. Jeff.
Haphazard methods of distribution of information. You'd think for a protocol sort of group like the IETF would be good at distributing information in a reliable and timely manner, and it's one of the jobs that we're really crap at. Geofeeds are a great example.
Right. Yeah. Yeah. Jumping.
Yeah, now I have a wide microphone. Two things. One is like the geofeed should be time-stamped and with TTL, the same as like DNS. The second thing is about the granularity. And the last thing I should add one more is like we have the geofeed format, and we also have an IETF draft or IFC on how to find it, but we should also have some guideline for network providers and geo IP providers and or content providers how to use geofeed properly, because geofeed does not solve everything. That's really important.
Okay.
Yeah, that's my point. Thank you.
John, were you up again, or was that all?
I was up again. I am up again. We haven't discussed this, so I don't know if you want to put it in the gaps, but discovery of geofeeds and the veracity of the validating the provenance of the geofeed is not something you've discussed.
I think it was alluded to at some points, yeah. Eric?
I don't know if we discussed this, but I think kind of touched on it in some places, is there would be, it's as a feed provider, it's really hard to tell what the status of your entries are in feed consumers. Like some of them you can check it, others like Google, there's no way to realistically check that. Is having this could be an area where having a consistent or standardized way for someone who's publishing a feed to go to the various IP geo providers and say, and do lookups to figure out kind of what has and hasn't been incorporated and and if there are errors could help close that feedback loop and make it easier to operate these in a consistent fashion.
Great. Sid?
I think the role of regional internet registries, the IRRs, in encouraging publication of geofeeds and by extension verification of geofeeds is critical. So I think we need to talk more about the role of IRRs in pushing this.
Robert?
I found the button. There was talk about location of the endpoint versus location of the user. And I
I think this is
think
kind of
that
like
was
this one.
mentioned today. Well, so small letters. Yes, thank you.
Yeah. Yep. Great. Drew?
One point about the attestation or of the validation of the geofeed as well. Like we need to explore ways to do that.
Yeah. Okay. Christopher.
Yeah, it's a shame that we only had the one talk on privacy, but there's another issue that's like part of the privacy issue that we didn't have a chance to talk about, but I think is related, which is how there are unintended consequences from like data privacy opt-outs, how sometimes these can impact like users who are not actually using the IP address in certain circumstances. There's all kinds of unintended consequences that happen when IP addresses are removed from IP geodatabases. So that's like another thing to consider is like, what is the negative impact to internet users from these opt-outs, and how can we mitigate them while still protecting people who have, made valid requests?
Nalini, then Glenn.
So this, I don't know if this is what Drew meant by attestation, but I think something where the endpoint maybe either consents or gives cryptographic attestation as to where it is, and maybe like to say it's okay to see where I am, and then those who don't, well, then we know who these are.
Glenn.
Yeah, I just wanted to say that one takeaway I also had was that while there are situations where privacy revelation of your IP address is a bad thing, there's a corresponding situation where a wrong answer for that revelation is also a bad thing, and that this comes back to this mechanism for fixing or at proper attestation that it's a correct answer. Because if as an example, if I was traveling in an area which had a line I cannot cross because I've wandered into a restricted zone, like a military zone, even if I haven't done that, if my phone says yes, you did wander into that zone, but I didn't, that's a bad thing.
Yeah. Debian?
Yes, we can also consider the update frequency of RIers actually.
Tommy Sultan.
We've talked about
maybe. Tommy first. Sorry.
Maybe we want to have a conversation about having a flag that says this particular IP do not locate, and as part of the protocol.
Okay.
So we've talked about privacy and granularity and so on. Multiple comments on the chat mentioned city level is or should be enough. What if a city has 10 houses altogether? Is that better than a postal code with 10,000 or 1 million users? So this level of granularity, I would be very curious to understand.
Okay. Debian, was your hand up newly, or is that from before? And Christopher, same thing. Drew?
I'm not sure whether this fits in at this level, but there is this meta question at the architecture level that also we should tackle. That there is a tussle between we are sort of abusing the IP address in this system, and is that if we are thinking about designing the new thing, I think we need to focus on that architecture question as well. And how do we take that tussle into consideration?
Yeah. Okay. Great. No hands up now. There's a good list. you have the link to this. If there are other things you think of, drop them in. We're going to have more broad discussions tomorrow. John is going to lead us through discussions of future directions. We have some interesting talks, but we're also going to have a lot of time to synthesize things and talk about how we want to go forward from the workshop. We are over time. Thank you for those who stayed here. Really appreciate all the conversations and insights. This was really great, and I love hearing all of your perspectives on this. So, yeah, thank you all, and I will see you tomorrow.
Yep.
Thank you.
Thanks. See you tomorrow.
All right.
Thank you.
Bye-bye.